Hey savvy people, it's Savvy Nick here, and today I'd like to welcome you to the C++ programming tutorial where we're going to go ahead and go through my entire 10-part series that shows you how to program using C and C++, as well as set up Visual Studio Code in Linux. If you're new and stopping by to watch a video today, please make sure to subscribe below and hit that notification bell for more programming videos as well as Linux videos. If you're following along on Windows, you can also do so fairly easily. You'll just have to make sure to go ahead and install the GNU compiler tools. That's GNU compiler tools, and you'll be able to compile and use Visual Studio Code in the same way that we are in this video. I'll first start out by showing you how to install Visual Studio Code on Linux. Specifically, we're going to be using Ubuntu, and then we'll move on to installing a few extensions to make our lives easier and creating our first make file so we can go ahead and compile multiple objects for our project and then start programming our project, which is a simple list that keeps track of a user's list of items and will support multiple users. After we've programmed everything, we'll take some time to learn about Git repos and version control. And finally, as a bonus, we'll go through how to also use debugging in Visual Studio Code. In case you run into problems in the future, you'll be also well equipped to figure out what those issues are and where they're coming from. Well, without further ado, we'll get started. This is going to take a while, so you might want to take breaks, but by the end of this, you'll be well equipped with creating your first C++ program and learning all the ins and outs of getting your environment set up and using it efficiently. Let's go ahead and show you how to install it. In Ubuntu, it's very easy graphically. You can go to the Ubuntu Software Center, click on that, and it's also easy to install on various other different Linux distributions. If you need help installing Ubuntu or many other different types of Linux distributions, you can go ahead and find plenty of installs on my channel. I'll go ahead and supply a link in the description to a video for Ubuntu. The great thing about Visual Studio is that it's available for many different distributions, and we're going to focus on trying to make these tutorials as generic as possible so users of various different types of Linux distributions, as well as people on Windows and Mac OS who are interested in programming, can follow along. So with all selected and this little magnifying glass so we can search, let's go ahead and search for Visual. Should be the first thing that pops up here, and it is. And of course, the great thing about Visual Studio Code is that it's available for almost every platform, so you can go ahead and simply use this application across Linux, Mac OS, Windows. We'll go ahead and click the very first option here. It tells you that there's Visual Studio Code available, which is a lightweight but powerful source editor. Let's go ahead and hit the install button. For more information about it, there's information here at the bottom about the current version and some of the languages that it supports, which there's much more languages because of something that they call extensions. Let's go ahead and hit install and let the install begin. So put in your administrative password and authenticate that so it can install. And make sure you take a second and subscribe so you can follow the series along as we're releasing videos here on the channel. And once the application is installed, all you have to do is hit the launch or go ahead and search for it. So once you've opened up your new install of Visual Studio Code, the IDE will show you a welcome page, which just runs through a few items here, things that get you started, as well as help content here at the bottom, some videos, tips and tricks, repos, etc. there. On the right hand side, it gives you information of how to customize the IDE, as well as learning more about it and the commands that are available for it. The first thing I'm going to do is again focus on this right after we go through what's available here up top in the drop downs. File allows you to do things like you would expect: create new files, new windows, open existing files or workspaces, and edit preferences, as well as make saves. In edit, you can undo, redo, cut, copy, and paste. Also find various search patterns that are available throughout your projects. A selection just allows you to select, move lines up and down, as well as copy them, and also add various things. So view is always important since you can go ahead and edit your appearance in here. as well as edit the editor however you like it, so you get a nice workspace that you can use. On Go, that just gives you some shortcuts while you're programming. Debug allows you to use the debugger, start, stop debugging, and put in breakpoints. And then on the terminal side, you can actually build the current application that you're working with and even run it. And on help, that just allows you to get more help on how to use the IDE, as well as various different types of documentation and notes, as well as checking for update. On the left hand side of the IDE, we'll go ahead and minimize these real quick. You'll see that you have something called Explorer, and Explorer is just really your project explorer, which allows you to open various editors up, and what they consider editors are just pages on the right hand side that you are working with and making edits to. Folders are just folders on your file system that you have opened, and those can really be considered projects, which we'll create one in a moment. And then on the bottom you have outline, which we won't focus on quite yet. Let's go ahead and exit out of here, and as you can see, it says that there's no open editors anymore, and it defaults you to some shortcuts here on the right hand side now. Search will allow you to search through various different folders and replace items inside of various files that you're searching through. You can make them case sensitive and even specify what types of extensions you are targeting. And then on the source control, you can actually get Visual Studio Code working with a repository, so you can make programming a lot easier on yourself, allowing you to commit and pull down commits directly from here. We'll get into how to use this later, but just know that you can get this working with something such as GitHub and use a repository. Next is the debugging configuration. You can actually set up a debug configuration and then watch various variables on the stack, as well as expressions that you might add in, which you can add through here, and view what's currently on the call stack, as well as what breakpoints you have available. Finally, an important part here, the extensions. Extensions are just add-ons from people who have submitted them for Visual Studio Code. That makes your life a lot easier. We'll actually be installing a few extensions in order for us to be able to run a C++ program in Visual Studio Code here. So let's make the view a little bigger so you can kind of see what I'm doing here. So zoom in, that should be pretty good, and then I'll go ahead and put it in the full screen mode here. If you made it this far, go ahead and take a moment to like the video. It really does help me out. And let's go ahead and search the marketplace for a C++ app. So if we just type in C++, we'll see a few options here. And the first option is actually what we want, the C++ app. And if we click on it, we'll see more information about it. It says that it allows you to debug C++ applications, browse them easier, as well as automatically fill in functions from available libraries. Makes life a lot easier while programming in C or C++. And you can see here at the bottom more information on the package. Let's go ahead and install this package, or as they call them, extension, and the IDE will tell you once it's installed and enabled. Next, I want to grab one more, so let's go ahead and type in run up here on the top for extensions, and what we want is the code runner. This is a great application for multiple different programming languages that allows you to build and run your application right in this Visual Studio Code. I suggest using this no matter what language you're using, because it's available for many different languages, and you can see all of those various languages here. So some of the main ones, of course, is C, C++, Java, JavaScript, Python, PHP, Perl, Ruby, and that's just a few of the overall available ones. Let's go ahead and also install this package, and it tells me that it is now enabled globally. And since we got those two packages, now we can go ahead and create a program. So going back to the Explorer, we're going to go ahead and open up a folder. Let's go ahead and click the Open Folder button. This is where our project's going to exist. So I'm actually going to use the SavvyNick Documents directory. So if I click Documents, I'll go ahead and add a new folder in here. I'm just going to call it Simple List for now, and I'm just going to create that. You can, of course, call your project whatever you want, and it could be located in any directory that you want. Since Simple List is fine by me, I'm going to go ahead and hit the OK button. Give it a moment to refresh real quick. And now you see that we have Simple List available here. And under Simple List, we can now add a new file, a new folder, refresh it, as well as minimize or maximize the Simple List. Also, if you right-click, you can see that you can add a new folder to the workspace, as well as edit settings, create new files. So just know that that's an option. I'm going to go ahead and exit out of this welcome screen, and then I'm going to create a new file. And that new file will be called main.cpp. This is pretty typical of C and C++ applications, naming the file main.cpp, since the C++ compiler looks for main first in order to execute it and run your program. So since it's the starting place, main.cpp makes sense to use for the name of the file. So let's go ahead and create that main function. Here at the bottom, you'll get occasional recommendations. So it says that there's a newer update for one of the C extensions that we just got finished installing. So I'm just going to say to ask me later again, since I don't want to install it right away. But of course you want to stay up with the latest and greatest in your extensions. Let's go ahead and create that main function. The first thing we'll have to do is include the IOStream library so we can write in and out of the console. Once we've included that library, we're going to go ahead and define int main, the main function. Keep these guys together, and then let's put some braces, and then in between those braces we'll put our statements in. The statement that we're going to put in here is just a simple hello world message to our console, showing that our program is running and that it can spit something out into the console. The way we do this is, let's go ahead and do std : here, cout. So cout's a function supplied by the IOStream library that allows us to print out characters to a console, and those characters are going to be hello world with an exclamation point. And I'll use one more standard library function called endline, or endl, and then I'll put a colon at the end to terminate my statement. And all that this does is creates a new line in the console after spitting out hello world. So finally, the last thing is I want to return something. So this is just to tell whatever's executing this program that things have successfully ran. So we've defined a data type of an integer, and that integer we're returning after all these statements inside of main have been ran and ran successfully is a 0 to pass out of this function. Another thing to focus on is, as you see this little circle up here next to main CPP, that just tells you that there are unsaved changes currently. So go ahead and hit Control S or do File Save in order to save your program as it is currently. And once you've saved it, you can simply run the code by hitting the play button up here in the right corner. So let's go ahead and do that. Hit the play button, give it a moment to compile and execute. And as you can see, what happened was it was our extension that we added in, that code run extension, was executed a command which changed directories to our simple list project and ran a compilation of the main CPP and outputted a main program. And finally, it ran the program here in the directory that it was located in. So after all that was done, we see that our program spit out hello world exclamation point to the console, and it created a new line, which you can see here since we have a little bit of space before the program executed. And everything was done in 1.71 seconds, and you can see that that program exited with a code of 0, which is great. We'll go ahead and talk about debugging in the future whenever we start using it with our own program that we end up creating. Instead, now I'll go ahead and exit out of here, and then I'll show you how to install Visual Studio through the terminal. It's just as easy as doing it through the graphical interface, but this is for users who don't necessarily have a graphical interface to use in order to install Visual Studio and maybe want to install it on a different distribution rather than using Ubuntu. So some of the ones that I've already tried are Arch Linux, Kali Linux, Fedora, and CentOS, or really any distribution that has a package manager that can handle RPM packages or APT packages will be able to install Visual Studio Code. So it makes it a great IDE to use across various distributions of Linux. So let me prepare things real quick. And now the second way we're going to install Visual Studio Code is we're going to go ahead and find the deb package for Ubuntu here. And we'll do that by using a browser in order to find Visual Studio. So I think if we just type in Visual Studio Code here, that will find the proper package. So Visual Studio Code, the first option here, I'll put a link in the description below. So we're on the https://code.visualstudio.com. And then here we can see that we have different types of packages available. We can either download it for Debian Ubuntu or Red Hat Fedora, and it gives us a few more options, as well as Windows and Mac OS. Since I'm on Ubuntu here, I'm going to go ahead and download the .deb extension. So go ahead and use the stable version, and your download should begin shortly. We'll go ahead and save this file, and it will go into our downloads folder. It goes really quick. So I'm going to just hit show all downloads and show you that it's currently downloaded on the computer. Next, what I'll do is launch a terminal. So let's go ahead and find terminal. Open that up. Let me make the view a little bigger for you. Hopefully everyone can see that. And the next thing I'm going to do is do sudo dpkgi, and then I'm going to point to the current package, which is located in the downloads folder. So as you can see here, I got sudo dpkg space -i space the location of the .deb package, and then I'll put a colon here and execute another command as well. So sudo apt install, so that's sudo space apt space install space -f, which will help install any missing dependencies that we have for this package. I'll go ahead and put this command in the description below. Once you have that, go ahead and press enter. It's going to ask you for a password, put it in, and give it a moment to unpack the package and install it. And after everything's done running here, we should have the Visual Studio Code now installed. So let's go ahead and check. Go ahead, hit the Show Applications button here on the bottom left of Ubuntu, and then simply search for Visual Studio. If I type it in right here, there we go, Visual Studio, and launch it. And welcome to your new Visual Studio Code IDE. It's successfully installed at this point, so you can go ahead and follow the instructions previously explained in the beginning of the video to show you how to use Visual Studio Code just a little bit. But at this point, you are ready to go ahead and install a few extensions for Visual Studio Code, and you'll be able to run your application right away. So sometimes the setup can take a while just to get things right before you can get to programming. So it's very important that we install the proper extensions here in our Visual Studio Code IDE. What I have in front of me is the Hello World program that we created last time in the first part to the series, where we installed a few extensions for Visual Studio Code, as well as showed you around Visual Studio Code and how to use it in Linux. And you can also use it the same in Windows and Mac OS and platforms as well. So let me go ahead and make this my main view here. Give me a moment. I think it's zoomed in far enough, but we want to go to Appearance and then the full screen mode. That way we only are looking at Visual Studio. And I'm going to go ahead and make this a little smaller here. Actually, can't go any smaller, so that's where we'll keep it. We got our main CPP program here, and you see what's inside of that. We just have a main function, and in that main function we just spit out hello world. So since Visual Studio Code here doesn't have an easy way of compiling multiple files together, we will install a new extension called make. This extension will help generate a make file for our project and allow us to compile multiple source files together very easily, no matter how many we have. This will definitely be useful for down the road. Let's go to the extensions. As you can see, we do have two extensions that we installed from the last video, but we're actually going to search for another one. And these make files that are generated can be pretty involved, but make itself is an awesome tool which only builds changes in files that have been edited, so you don't necessarily have to recompile the entire program every time you make a change. Instead, it just compiles the small changes that you made in individual files instead of the overall project, saving you a lot of time. Let's see if we can find a make in here. think if we just type in make, we should be able to find it. And I don't actually see it, so let's go ahead and do C++ make. Maybe this is a better way of finding it. No, but what you can see here is the C/C++ make file. Let's try that. C++ make file. Well, that pushes it up the list a little bit more, but it's not obvious. This is actually the one we want. So it's called the C/C++ make file extension. And it has project at the end of that. So C/C++ make file project. It's been downloaded over 3,000 times. And it says it creates a C/C++ project with pre-configured make file. You can also scroll down and read more about it if you want, but it's a very easy tool to use and you don't actually have to create your own make file. Instead, it generates it for you. There's plenty of documentation available for make and how to create make files on the web, and we'll just focus on generating one here in Visual Studio Code today and not get too involved in the inner workings. We'll save that for another video in the future. Let's just go ahead and get this project compiled and running. So first, let's install this extension, and it should be fairly quick to install here. After we've installed it, we can go ahead and exit out and go back to, let's go back to our main CPP file in the File Explorer. Also, make sure to take a moment and subscribe to the channel so you can keep following the series, as well as viewing different content that's constantly being released about Linux and programming here on our channel. So after installing that extension, we're going to use the command palette in order to generate our make file. So if we just hit this little cog here and hit the command palette, or you can do Control-Shift-P as it says here, go ahead and you'll get a little small terminal to type into, or console. Let's see if we can search for make. And if we type in make, you see that we have this C/C++ make init project, and that's what we want. So after you click that, you'll get an option on 4 different things here, either a C project, a C++ project, a C only make file, or a C++ make file only. What we want is a C++ project because that's what we're going to be writing our project in. But don't worry because that also includes C. So go ahead and click that, and now a file will be generated right in front of you. As you can tell, there's quite a bit to this file here, but we won't let this confuse us too much. Instead, let's go ahead and just make small edits to here. So the section we're going to look for is this one right here that says make file settings can be customized. So it asks you for an app name. So what do you want to call this app? Let's call it Simple List. And the type of extensions that we want to compile, we want to compile C++ extensions or .cpp files, so that's fine for us. Another thing that we have here is the source directory, which the source directory will be wherever your project currently exists on the computer, so the directory where the project is. So let's go ahead and figure that out real quick. If I press Alt, I'll get some options here up at the top, so I can go ahead and go to Terminal. Let's see, actually I'm going to View and change this up so I can see an output terminal here. So terminal, hopefully there we go. So now I get a terminal to my Linux computer, and I will just print out where my project is currently located. So if I do pwd, I see that my project is located at home, SavvyNick, Documents, Simple List. Yours might be somewhere else if you have it saved somewhere else and you probably don't have the username SavvyNick. So make sure that you put in whatever directory that your project is located in. So I'm just going to copy that, and I'm going to change the source to be that location. So you can see my source directory is now home, SavvyNick, Documents, Simple List, and that should be enough changes for us in order to compile the project. All I do is save the makefile, which now it's saved. I'm going to go ahead and exit out, and now we have 2 files here, the main CPP file and the makefile, which are both located in the Simple List directory. And below here, we can issue a command in the Documents Simple List directory called simply make. If we press that enter, make will automatically compile any object that it finds in the Simple List directory. So it found a main CPP file and simply compiled that file for us and created an object and then even linked it for us. So make simply just went ahead through all of our files And since we really have one source file, the main CPP file, it went ahead, found that file, compiled it for us, and now we have an object that was created and a program that was created. So what did we call that? If I just do ls here, I'm just going to list out what we have. We have the simple list. And why is it called simple list? Because we told the makefile to call it simple list once it got compiled right here with the app name, simple list. So in order to run this, at least here in this terminal, we can just do /simple list. If we press enter, look at that. We have hello world, which is what the main CPP file should be doing. We have a main function, and that function just spits out some text called that says hello world and creates a new line. After that, it returns a 0, meaning everything executed successfully in this program. And congratulations, you've successfully ran your first makefile project. At this point, we're ready to go ahead and make some edits to the project and start our own simple list C++ project. We'll continue to build onto this project as the series progresses and plan on creating a simple program that allows you to create and keep track of a list of items. The program we'll be creating will be very similar to, let's say, a to-do list or like a reminder list, but a very simple version of that, which will use the console, this terminal, to display all the contents of the list, as well as make changes to that list. So this is great because we've made a lot of headway here. So we'll save that start of the programming for the next episode in the series, since at this point we should have all the tools necessary and extensions to properly build the project. And now that we have our development environment set up, we can finally begin programming our C++ program. So let's go ahead and jump right in. The first thing I'm going to do is just make this Visual Studio Code a little bigger so everybody can see. Let's just put it in full screen mode. So the first thing that we're going to do is include some functions from the standard library, and we want the IOStream functions. So this will just help us write and read from a terminal or console. It'll help us later down the road in order to pass information from the console to our program. And then we're going to do using namespace std and put a semicolon at the end to end our statement. What this does, this allows us to use the standard library functions without explicitly telling them they belong to the standard library. So let me give you an example. If you were to do standard cout, this cout allows you to print out characters to a console, and you have to tell the compiler where and what library that cout function is coming from. So you have this std in front of it, meaning it's coming from the standard library, and it is a standard output from the standard library. So since we defined a namespace up here, we don't have to do that anymore. We can just do cout, and then the compiler will recognize that you already told it you're using the standard library, and cout is a function inside the standard library, and it will automatically use that function. So just a little information there. Let's go ahead and delete that and continue on here. First thing we want to do is go ahead and create our main function. So let's do int. This will be the return type of the main function. And then we're going to type in main, and just a few things inside of here, some arguments. And the arguments that we want is another integer argument. And then we'll do argument count, so arg_count. And then char with an asterisk here, and we'll do args. This will be an array. So why do we have these two arguments here? Well, argument count is going to get a count of arguments from the terminal. So if a user supplies an argument, then we'll go ahead and get that passed in from the terminal. So this just gives you a count of the arguments. And then this here is a character array of the actual text that they pass in from the terminal. You'll see how this is used a little bit later whenever we compile. But just know that it helps us get arguments and text from the console and while they're running the program, when they initially start up the program. So let's go ahead and put some braces in and do one other thing here. We'll go ahead and do a return 0. We always want this in main because we expect to return something, an integer, and that integer is going to be 0 here. And all that 0 means is that the program successfully executed. So if main ran and there were no errors, you would return 0 and exit the and tell whatever ran the program that it exited successfully. Let's go ahead and make a save at this point and just make sure that we can compile things. What we'll do, if we press Alt, we'll get our menu back up here. And then let's go ahead and open up a new terminal, which we closed earlier. You can see that I am currently in Documents, Simple List, where I've created my project folder, the Simple List. I'm just going to do ls, and you can see all that's inside of this project. So we have a make file, which we created in the last video. Let's just do make, which will build and compile all of our source code into objects and then link them together. And after that, we'll have the simple list that we can run. So I can run it by simply doing this command here, the /simple list, and I just press enter, and there you go. It did run. Of course, there's no output currently, and all the program would do is return a 0 to whatever called it. We can't see that at the moment, but looks like everything ran successfully. There was no errors in compiling or linking. So let's go ahead and exit out of this terminal and return to programming here. Make sure to go ahead and take a moment and subscribe to the channel so you can keep following the series, and make sure to share it with others who you might think will benefit from learning C++. So the next thing I'm going to do is I'm going to do an if-else clause here. So I just want to check something here. So if our argument count is greater than 1, it's just a simple check here to make sure that we got an argument. So if we have an argument count greater than 1, then we want to do something. So we'll put some braces here and then a statement inside this if statement. And we'll save it like this for a moment here. And let's go ahead and make our else. So if the argument count was greater than 1, then we do something inside these braces. Otherwise, we're going to do something here in the else statement. So let's just print something out to the user. If there is not an argument, why don't we just print out and tell the user that there isn't an argument? And let's do cout, and then these angle brackets here, and then we'll do username not supplied, ... exiting the program. That should be enough to the user. And then at the end, we'll just do the end line. That's another function from the standard library. All it does is creates a new line in the terminal for us. It'll just make for better formatting here. All right. And now that we have that, let's talk a little bit more about this main function here and why we have the argument count and the args array. Well, this is so the main function is what really just defines the startup point for our program. And it can take in as many arguments as you want, and those are just values that get passed into your main function. So you can type in something to the terminal to run the program, and then behind that running of the program you can type in various arguments. So argument 0 in this array is always going to be the name of the program, and then argument 1 is going to be your first argument. So that's what those are for. And with that being said, we can go ahead and do something with one of those arguments. So the first argument that we'll expect from the user and the terminal is going to be name. So let's go ahead and define a data type called string. A string is a type of variable that we can declare in our program that defines an array of characters, such as a name or some form of text. So we can do string, and then what's our string called? We're going to call it a name. And what are we going to put in name? Well, let's go ahead and put that first argument that comes in through the terminal. So we can do that by doing args and then defining which array element we want. So it's going to be the first array element here of the arguments. Well, really, the first array argument would be 0, and that 0 argument would be the name of the program, and that's not what we want. We want the second argument, so that's why we have args 1 here. So all this line does is define a string data type and then a string variable called name. And in name, we pass the second argument from the terminal. So at this point, let's go ahead and save the program and try running it again. So I got it saved here, and then let's do Alt. That way we get our menu back, start the terminal back up. Once we have that, we can go ahead and compile the code by doing make again. You see that we got no errors, so that's great. Let's go ahead and just run the program once again. So if I just do this, we should get, let's see, username not supplied. So let's go ahead and do that, and look at that. We get username not supplied in the terminal, and it created a new line after this because we had the end line here. So created a new line, and now you get your terminal back where it's asking you for a command. So let's try another thing here. So let's supply an argument and see how that works. If we do supply it, then we shouldn't get this second message here, and we won't get any kind of a message. So let's do simple list. So this is again the name of the program that you're running, and then we'll just supply Savvy Nick because that's my name here. So as you can see, when running this together, we don't go through this else clause. Instead, it calls main, and it goes through here, and it realizes, hey, we got an argument, so the number is greater than 1 for the arguments because we have a name and an argument supplied this time, making it 2 arguments, right? So then we go ahead and just store that name that we supplied, Savvy Nick, into a string called name. So that was super easy there. And if you've made it this far, please take a moment to like the video. It really does help me out. Let's go ahead and close out of this terminal once more and complete the rest of this program. So up here, let's go ahead and define another function that we want to use. This is something they call a prototype. So we'll do void print menu. Print menu is what the function is going to be called. And we're going to be able to pass one thing into this print menu, and that's the name. So string name, because the data type of name is a string as we had defined below here. So we're going to actually pass this argument into print menu here in a moment. So that's why we want the same data type for the argument. You can actually change this name to be whatever you want, but since we're passing in a name, I figure we're just using name in order to define the variable that we're passing in. So the way that this function prototype works is you always define at the beginning what type of return variable you have. So void's a special type of return value, which just means, hey, this function doesn't actually have anything to return. So you can use void for functions where you don't want to return anything. And then this print menu here in yellow, that's just the name of our function. Inside these brackets here, we have any arguments that we want to pass into the function. So as you can tell, into the main function, we have, again, a integer type that we're returning, a main function. And inside the main function, we have 2 different arguments that we want to pass to. In the print menu, we only have the 1 argument. So why are we defining this print menu up here? Well, the main reason is when the compiler goes through, it goes from top down, and then when it gets to main, and if we made a call to the print menu function inside of main, it wouldn't recognize where that function exists because we might want to write that function definition underneath the main function. So if you put a prototype here, then the compiler will realize, hey, print menu does exist somewhere, keep checking until you get to it. So it's important that we put this prototype here before we start stubbing out our actual print menu function. And let's go ahead and do that below the main function here. So what is print menu going to do for us? Well, it's just going to print out some information to the user in the console using text. So let's do void again, just like our prototype has up here. We'll do the exact same thing. Void print menu string name, and then go ahead and put our braces here. And you might ask, why the redundancy? Well, I explained that before, but it's really just so the compiler knows that print menu is existing in this program and to keep searching further. So let's go ahead and do an integer choice. So the data type here is an integer, and we're calling it choice. This way, the user can make a choice using a number, and let's display a menu to them. So we're going to use the cout standard function to display something to the user. Let's just do, to make this pretty, a few asterisks here just to begin the program. And in here, let's do a /n. So this is a special type of character that also creates a new line. So instead of having to do the end line like we have up here every single time we want to create a new line, we can simply replace it with this /n. So let's go ahead and start using that. It just makes it quicker to program. So we'll put that in instead. And let's print out another set of characters to the user. We'll do option 1 is print list, and we'll put a new line at the end here. And let's print out something else. So option 2 is going to be to add to list, and again a new line. Let's put a period as well. And let's give them a third option. The third option is going to be delete from list. Keep it the same here. And a new line character. And how about a fourth option? So the fourth option is going to be just to quit out of the program with a new line character at the end. And finally, let's just go ahead and ask them for a choice. So enter your choice and press return. In here we won't put a new line character, that way they can supply that number for us, choice, in the same line as it says enter your choice and press return. You'll see that here in a few moments once we compile. Go ahead, put a semicolon and end that statement. And now we want to use something called syn. It's a function where we can read from the terminal into a variable, and that variable is going to be choice, which we defined as an integer. So now the user can supply from the terminal into choice an option which we can then parse through and figure out what they want us to do. So we can either print the list, add to the list, delete from list, or quit out of the list. So now let's go ahead and check to see if they selected whether or not they want to quit out of the list. So if their choice is equal to, let's see, 4, then we're going to put some braces here. We're going to exit out of the program. And we'll exit out with a 0 because that just means it's successful. So what's this exit function? The exit function, it terminates the execution of the program and then returns the status, and that status that we've supplied is 0, meaning everything has ran successfully. So now that we have that if statement, we can also put an else clause here. And in else, let's just say, let's print out something to the user. Let's just say sorry, command not, sorry. Well, let's go ahead and put sorry, choice not implemented yet. See, that's spelled out wrong. So that way they know we got their input, but we don't have anything to do with that input quite yet. So they don't have that choice to select, since we haven't come up with functions for the rest of these choices yet. So let's do one last thing in main. Let's go ahead and call this function print menu, because currently we're going to run through main, but we're not going to actually run through this function because nothing makes the call to it. And we can do this simply by creating a new line here and doing print menu, that's our function name, and passing in a string. What's that string? Well, it's name. So let's go ahead and pass in name here. And now we should have a start to our program here, our simple list. Let's go ahead and compile it, make sure that there's nothing wrong with it, and then we'll go ahead and run it. So again, Alt here, let's start that terminal back up. We'll build it by doing the make command once more, and it did pick up on a problem, and this was my fault because I did only one equal sign, meaning I'm reassigning choice to equal 4, and that's not what I want to do. I want to make sure that it is equivalent to 4. So if choice is equivalent to 4, you have to do that with 2 equal signs. Then I want to do something, otherwise it wouldn't work. So the compiler was pretty smart in recognizing that. It just gave you a warning. It did compile successfully, But let's go ahead and remake this, and I shouldn't get a warning here. Oh, let's first do make clean and do a save again. That's why I couldn't build it. So I didn't see any changes. Again, it's very smart here, make is. So we'll do make again, and now I don't have any of those warnings that we had before, and I should be able to run my simple list. So let's just run it as simple list without specifying a name at all. And you can see username not supplied, exiting the program. Great, that works fine. So let's supply a username this time. So simple list, and we supplied a second argument with Savvy Nick, my username. Go ahead and press enter, and look at that. Now we have a list of choices supplied to us, 1 through 4. So what do I want? Let's go ahead and hit 4. So I'm going to quit out of my program, and look at that. It successfully stopped the program. And the last thing I should try is, let's go ahead and supply simple list with Savvy Nick. Move this up a little bit. And you see that we're printing the list, adding to the list, deleting from the list, or quitting. So what if I choose choice 1? What's going to happen? Well, it says, sorry, choice not implemented yet, which is exactly what we would have expected. So let's just run through the program once more here that we've created, exit out of this terminal, and this will be a pretty good stopping point. So we created this main function and a print menu function, and inside the main function, if a user supplies a second argument, we check that, and then save that argument into a string name. Then we go ahead and print that menu with the name, and we call print menu, which displays a small list of choices for them and checks to see if they want to exit the program. Otherwise, it just tells them that we haven't implemented anything for the choice that they selected. So if they didn't supply an argument, we just say that a username wasn't supplied because that's what we're expecting for the second argument. And if you make it out of this else statement or if statement, then we just return a 0 saying that the program successfully executed. This here that you see in front is from the last episode and what we've currently programmed up until. So we just have a menu being printed out of our main program. So the first things first, let's go ahead and define our prototypes for the new functions that we'll be adding. Let me go ahead and put some more space up here at the top. So the first one we're going to add in is a print list feature. This will allow us to print the list out that's currently in our simple list. And since this print list function will not return anything, we're going to go ahead and use the void return parameter. And there will be nothing to pass in, so there's no arguments here. The next function that we'll need to add in is the void add item function prototype. So let's go ahead and end this line with that semicolon there. And then the next function that we're going to add, or function prototype, is again no return parameter, so we're going to use void for that. And we want to be able to add an item. So we'll type add item in, make sure that we end our statement here with a semicolon. And what this function will do is it'll take an input from the user for a new item and add it to our list. And this add item function will add our item supplied by a user to a vector. And we'll use a function in the vector class template called pushback, which will dynamically adjust the size of our vector and maintain itself automatically for us. That's why vectors are very great to use in these types of situations. So let's also add one more function here, void. Again, we're not going to return anything out of this function, so let's use void delete. Oh, might want to spell delete right. Delete underscore item. And this one will simply delete an item from our vector, aka our list. So let's go ahead and make sure to save this. And one other thing I wanted to do is go ahead and define a global variable here. And all a global variable means is that we'll be able to use this variable in any of the scope below this. So if it was in a function, we couldn't use it outside of the function. So we want to make sure that it's outside of every function. Therefore, we can use it in any function. And with that being said, we're also going to introduce a new type of variable. It's just like an integer or a string that we've talked about before, but it's called a vector. And all a vector allows you to do is dynamically store a collection of variables of the same type. So in our case, we're going to store the items, and they'll be strings because we want some text in our list. We'll do vector, and then less than symbol, string, well, not strong, string, and then what we're going to call our vector, we're going to call it list. And the reason we have this underline here, this red underline, is because we haven't included the function vector from the standard library. So let's go ahead and do that at the top. If we go ahead and include the vector functions, we can do that by doing this include vector. Now we have access to the standard vector class. So you can see here, let's go ahead and make a save, and after we added in the vector function, you can see vector is now resolved and our ID knows what it is and how to find it. So no more problems there. So again, what we have here is a vector, and it's called list. And what type of a vector is it? It's a vector of strings. So you can go ahead and put as many strings in this list as you want, and that's exactly what we're going to do. In order to drive this home, you would define a vector like this. So vector, and then we'd go ahead and put these angle brackets. Inside the angle brackets, we always want to put our data type and then a name for the vector. So as you can see here, we have vector, vector. So we're defining a vector of what type, string, so data type, string, and the name, in my case, is list here, and you would put a name, whatever name you'd like to use. So let's go ahead and delete that. I'm not going to use that. So let's continue on by doing a little bit of cleanup here. I want to pull out name that's currently in the main function. So let's pull it out so it's in global scope, just like our vector is. So we'll do string, define name up here, and that's all we have to do. So we have a name of data type string. Let's go ahead and delete this line now and replace it with name equal string and then args1. So this way we have name available globally instead of just in the main scope. Actually, just inside this if statement, to be completely correct. So now we're assigning name by converting characters to a string and then storing it in name. That's all that this is doing here. And it's just taking the second argument that comes in from our terminal, as we explained in the last video. So now that we've done this little bit of housekeeping, let's go ahead and start creating some of our functions here. I'm going to make sure to save this. So now I want to go ahead and create one of these functions that we prototyped above. Let's do add item first. So we'll go down to the bottom of our program underneath the print menu function, and we're going to use void to match our prototype since we don't return anything. We're going to call it add item as we did before, and go ahead and define our function in the statements inside of it. So the first thing we're going to do is just cout. So print something to the console, and let's go ahead and just put a bunch of new line characters here just to kind of clear the screen. You can put in however many you want in here. Next we're going to print out another thing. So after all those new lines, we're just going to call, let's see, add item. So they know what's about to happen. And then we'll do another cout to type in an item and press enter. And we'll want to give them a little space here so they can enter in whatever they want. And we won't put a new line here, but I did forget one up here, so it does start a new line. So new line character, and then we'll get this message, and after this message we'll allow the user to enter in their information right here where we have this space basically. So let's go ahead and define another string called item, and then we're going to capture text from the console and put it in item using the function syn. So syn into item is the way I think about this. And then what we're going to do is use that globally defined vector of strings, and as a vector class we can go ahead and use functions that exist inside of it. So when I hit this dot, you can see that we get a list of various functions that we can use. Well, most of these are functions anyway. There are some member variables as well, but what we want is the function called pushback. So let's find pushback. Here we go. So if we use pushback, we can go ahead and push back an item into our vector list. So if we just go ahead and put in an item, since item is a string, we're allowed to pass item into our vector of strings. And all that this does is pushes the item back to the bottom of the vector. So think of the vector as sort of like a little queue of items, and we keep pushing an item back into the queue every time we issue this command. Next, we're going to just tell them that we successfully added an item to the list. And then let's go ahead and clear the screen again. So a few new lines here. Blend this statement with a semicolon. And next we're going to go ahead and clear out the input buffer for the main menu, so we can go ahead and show them what they've added, and we'll print the menu after adding the item. So first thing we want to do is go ahead and clear that input buffer by doing sin. And now if we do dot, we'll get a bunch of functions and members again. And we should choose one called clear. So we can just start typing in clear, and then you should get it. So clear is a function. So we need these braces here. Let's go ahead and put a semicolon. This will just clear any type of input after we've already taken input from the console. This will just make sure that there's nothing stuck in the console buffer. So let's go ahead and call the print underscore menu function after this, so the user gets to see what's currently in the menu. So the user gets to see their menu of items. And right now there's a problem because we don't have enough arguments here. So let me look at our print menu. Well, it requires a string name. So we're going to go ahead and just pass name in, since that's global. And that's why we moved it outside of the main function. All right, that's pretty good for add item. Let's go ahead and just make sure this can compile, since we've done quite a bit of coding so far. And we'll do that by hitting Alt, going back and opening up a new terminal. And let's just go ahead and issue the make command again. If you need help getting this make set up, you can watch episode 2. And also, make sure to take a moment and subscribe to the channel so you can keep following the series, and make sure to share it with others who you might think would benefit from learning and following the series. We'll run the program by doing simple list and then typing in a name. So Savvy Nick for me, and everything seems to be running fine. I'm just going to enter 4 to quit out of the program, and then let's continue programming. So I'm going to exit out of the terminal. The next function that I want to add in is delete item. So since we can add an item, let's be nice and allow our user to delete an item from the list. So we can do delete item, and we already made a prototype above, so the compiler will find our function here. And we're going to print out, again, something very similar to what we did before, but we'll do delete item so they know what action is about to happen in the terminal. And then let's go ahead and print select an item index number to delete. And we'll also put a new line here. Next thing we want to do is go ahead and display the list of items, since we told them select an item, and specifically an index number of the items that they want to delete. So we'll do an if statement here just to make sure that we have something in our list. Otherwise the program could crash. So if we do list.size, size is another function of the vector of strings that we have that's built into this vector class. And then if the list has some size to it, meaning there are items inside of it, we will print out the item with an index. So next we'll do a for loop. So a for loop is just a quick way to iterate over a few statements that you might have. So what we want to use this for loop for is we want to go through every item in our vector and spit it out to the user so they can select one of the item numbers in order to delete it. So we can do this by doing for, and then for is a function, so we just say, let's start with some sort of a number. Let's define a new integer, so int space I equals 0. So all we're doing here is defining a new integer called I, and it's equal to 0 to start out, and will be incremented inside of this for loop. This is just to keep track of what index that we're currently on, and that's why people tend to use I in here. So next we want to do something else. So the first part of a for loop is where you define any variables that you might want to create. The second portion is a condition that you want to check. So in our case, we want I to be less than the list.size function. So list size will return the size of our list, and if I is less than that size, we'll keep going through our for loop. So here's our condition, and then finally we want to iterate I and increase it by one number every time we go through this for loop. So we can do this by just doing I plus plus. This allows I to be incremented. Next, we'll go ahead and define what statements we want inside the for loop. So we want to print out something to the user, and that something is the current index that we're on. We start with 0, and we'll just do that by putting I. And cout's very nice because it allows you to concatenate variables and strings together, and we can do that by using the less than operator. So we got cout. What are we going to pass to cout? We're going to pass I is an integer, and it'll first start out as 0 and then increment itself every time it goes through this loop. The next thing we want to spit out is just some text, and that's just to make it look a little better. So we'll have I, and then we'll concatenate a colon to it, followed by the actual item in the list. So if we do list with these brackets here and then the I inside of it, it'll increment the list starting from 0 up until it reaches this actual size of the entire list, and keep spitting out each item using this right here. So finally, we just want to put a new line at the end here. That way everything looks pretty, and we keep getting new lines every time we spit out an item from the list. And that should be sufficient to get items from the list so the user can select from them. So we have this if statement here, right? So the for loop is inside the if statement. So if the list size is greater than 0, then we execute this for loop. So let's do an else. What happens if it's not? So that means there's no items in our list. So we should just print out to the user that there are no items to delete. And let's make sure we put a new line here as well. Last thing we want to do is go ahead and show them the menu again. So we can just call print menu again. And we'll want to make sure we pass in name since it does require an argument. And now we have our delete item function stubbed out, which is great. We're going to add one more final function. So let's go ahead and save. So the last function we'll create is the print list function. So we'll do that by defining it again like we did in our prototype as a void return parameter. And the function is called print list. Let's go ahead and put our braces so we can put our statements inside. And we're going to print out, again, a bunch of new line characters to begin here. I don't know how many. Let's just do that. We'll just move the screen down a little bit for the user. Next, we're just going to print out that we are printing list. And then we're going to do, again, another for loop. So again, a for loop is just a way to execute the same block of code repetitively until some condition is met. So in this case, we're going to print out our list of items one by one, followed by a new line. And we'll create a variable called list index, which is going to be an integer. And that list index will increment by 1 until the list index is the same size of the vector. Again, every time we run this block here, this for loop that we're going to create, the list index will increment. So let's go ahead and write our for loop in. So we do for, and we said we'd make an integer called list index. And let's set that equal to 0 initially. And let's keep some of these together here so we have the same formatting as above. And then we're going to check a condition. So when list index is less than the list size, we'll keep going through our for loop. And then we want to make sure to increment list index every time through the loop. And we can do that by just doing list underscore index plus plus. Finally, let's go ahead and write our statements inside the for loop that we want executed. And all we're going to do is print out our list of items. So we're just going to let's put an asterisk and then do list of the list index. And we'll run through this one more time here so you get a good understanding. And let's put a new line at the end here. So the for loop will begin executing with list index equal to 0, and I'll create a new integer only in this for loop scope. And while it's doing that, every time it goes through the for loop, it will increment the list index by 1. So it starts at 0 and goes up 1, 2, 3, 4, etc. until it gets to the size of the list, which means there's no more items that exist. Stop printing the items out. And then of course you have cout printing to the console, an asterisk concatenated with a list item concatenated with the new line character every single time. And as the list index increments, it'll increment what location it's at in the vector, and that vector is our list. So let's go ahead and add something here. Let's print out to the user m is menu in a new line character, and then we'll do another choice here. So character choice, and then we'll allow the user to put something into our choice character from the console. And if, let's put another new line there, if the choice is equal to a character called m or lowercase m, because it is case sensitive here, and I misspelled choice, so let me fix that. If it's equal to uppercase m or lowercase m choices, well, then we should do something. So we're going to print the menu. Otherwise, we are going to print out that we have an invalid choice and that we're quitting. All right. So last thing here, print menu requires an argument, so that's why it's giving us this little red underline. So let's go ahead and put our name in there, and then we should be good. Also, there's a semicolon missing at the end here. Let's go ahead and save that. And then we're going to go to the top here for the main function and just look at it for a moment here, because I don't believe we make a call to the print list yet. So let's do this. We will get the name, print, and then call print menu with that name. And in print menu, let's go ahead and add in our options here. So right now we only have choice 4, so we need a few more choices. Let's do an else if clause here. So this is another type of an if statement. You have if, else if, and then else. So this will check this first condition first of choice equal to 4. If it's equal to 4, then it executes this statement inside. If it's not, then you can check a second condition. Well, else if what? And then if this condition's met, so let's say choice is equal to 2, then we can do something else. And again, we can keep doing this. So we can do as many as we want here and make as many choices as we want. So if choice is equal to 3, what do? We do something else. And the last one would be else if the choice is equal to 1, then we want to do something. So this just makes it easy for us to check multiple conditions by using else ifs following an if. And then if all else fails, then we go to this else statement. So we first start by checking if choice 4, else if choice 2, else if choice 3, else if choice 1, else we go and do this as a backup. So what will we do if the choice is equal to 2? Well, we should add an item. I believe that's what we wanted to, right? So, yep. So we can look here in our menu. We have 1 is going to be print a list, 2 is going to be add to list, 3 is delete from list, and 4 is quit. So 4 we already have, 2 we have now. Let's go ahead and do 3, which is deleting from the list. So we'll call the delete item function. And finally, choice 1 will lead us to printing the list. So let's go ahead and save this and compile at this point to see how our program is working and if it's running correctly. We've added quite a bit to this at this point. Great job if you've made it this far. So go ahead, hit Alt, open up a terminal, and then in our terminal, let's go ahead and run the make command first to make sure that we compiled successfully. And there is a couple warnings here, it seems like, but I think we'll be fine. It says that we are comparing different types of numbers, basically. So one is of data type integer, and the other one is an long unsigned integer, so it doesn't have a sign, where a integer can have a sign. So that's why the compiler is complaining a little bit, but that's not a big deal. We can fix that later. The code will run just fine regardless of that. It's basically just saying, hey, look, you have two different data types that you're trying to compare against each other, and you might fail in the comparison because of it. But I'm pretty confident that this will work just fine. So let's go ahead and run it by doing the simple list, and then followed by a username. So mine's Savvy Nick. And here we go. So we have these options here. So we can print a list, add to the list, delete from the list, and quit. Let's go ahead and print first. And it says it's printing, but there's nothing in there. So we could probably make that a little smarter and tell them that there's nothing in there. Let's go ahead and return to the menu by typing an M. And now let's go ahead and add to the list. So number 2, and it says add item. And you can see we cleared the terminal a little bit for them. So type in an item and press enter. So I'll just do item number 1. Very creative, I know. So we got a sorry choice was not implemented yet, so something went wrong. Let's go ahead and check. So I put in choice number 2. So what happens with choice number 2? 2 will add an item. Okay, so we'll look at add item. And inside of here, we print out some new lines. We do an add item printout, and then we ask them to type in an item. We create a string called item, and we put in whatever's in terminal into item. Finally, we push back that item into our vector list, and then we print out successfully added item to list. So did we get that? Let's check the terminal. Yes, we did. So we've successfully added an item. Next, we do the sin clear. So this should clear anything buffered in our console. And then we print out a menu and a name. But we get this sorry choice not implemented yet. So where is it stopping? We're going to go look at print menu. And for some reason, it thinks that we've applied a choice right after we've added an item. So that's really our problem. Unless for some reason I hit enter twice. So let me go ahead and try running it one more time here. So I'm going to just add an item to the list. I'm going to just do item 1 for short. I pressed enter. And it looks like we did add an item. Let's check. Well, it says successfully added an item to the list. Great. And I'm going to go ahead and press 2 again in order to add another item to the list. We'll call this item 2. Press enter once more. So it looks like it's working now. My thought is that I hit enter twice and I didn't give a choice, so it automatically went down to the sorry choice not implemented and then went out of the print menu function. So we'll fix this at a later date because it could be a little smarter here and just ask you for to pick the correct menu item, but we're not doing that. So we'll do that a little later. Let's continue here and go ahead and do option 1 to now print the list. Do we get anything in here? And yes, we do. So we get a printing list, item 1, item 2. Now that does look a little goofy here. So what am I missing? I'm probably missing a new line character somewhere. But we did get both of our items that exist in the vector. So let's go ahead and look for printing list. So here's print list, printing list. Well, of course, we're missing a new line character here. That's why we didn't see one right here. And now you can really tell what happens if you don't have a new line. Everything remains on the same line. So go ahead and save that. I'm going to go ahead and exit out of here and then recompile with make. And we'll run the program once more. Let's go ahead and add an item to the list. Item 1 again. We'll add a second item to the list, so 2, item 2. Then let's print the list with 1. As you can see, now it looks better. Printing list, item 1, item 2. Hit M for menu, so if you do a lowercase m, it should lead you back to the menu, and it does. Let's go ahead and finally delete from the list with option 3. It says to go ahead and enter your choice in. Well, we have 2 choices, 0 and 2. So let's see, we have a little bit of a mess here because first, this doesn't look too good. We forgot a new line, it seems, after delete item. So let's go find our delete item function. And sure enough, we missed one right here. So I'll save that. That'll make it look a little better. And at this point, we haven't really implemented a way to delete the actual item from the list. We'll do that in the next episode. But we'll just go ahead and fix this little new line issue. So if I go ahead and exit out, if you want to exit out of the program prematurely, you can always do Control-C. That'll exit you out. And then I'm going to not rerun it, I want to rebuild it. So make, and then we'll do simple list with the username. And after we've done that, now we can go ahead and add to the list again, item 1. And then let's again add to the list with option 2 and item 2. And now let's go ahead and print our list. We have item 1 and item 2. Let's return to the menu. After we're back at the menu, let's go ahead and delete from the list with option 3. And you can see now that we've spit out the 2 options for them to delete, but we haven't quite yet implemented a way to delete them. Again, let's do that in the next episode since this is running a little long at this point. But great job, everyone. You've now successfully created a few more functions and made a program that does allow users to go ahead and input their list as well as print it out so they can see what list of items that they have. This is a great start to the program at this point, and it's actually functioning at some level. We'll of course clean this up and make it a lot better and more user-friendly. What I first want to do before going ahead and creating a class is let me change something up in main that I found wrong last time. So down here we had a problem, I believe, with the list index. And let's go ahead and run the program real quick just to make sure that I'm right. We'll go ahead and go to the terminal, create a new one, and we'll run our make command here. It says nothing to be done for all. We're going to make clean first, so we clean everything up and run make again. And as you see, we have this warning here that our comparisons are 2 different things. One's a long unsigned integer, int, and then another one is just an int. So one is signed and the other one is unsigned, meaning one can exist in a negative notation and the other one cannot. So in order to make them the same, what we can do here is we can typecast. So if we just type in parenthesis int parenthesis close parenthesis, then what this will effectively do is typecast, change the type of this data type, if possible, to an integer. So that should get rid of at least one of the warnings. I believe we have another one that we did up here, and we do under delete item. We should also do it here. So if we just do int in parentheses, this will typecast this list size, whatever it returns, into an integer. Now this can't be done with everything because you might lose the proper value if you try typecasting from one variable to another variable and the data type sizes just don't match up. So think of it as not enough bits can be stored in from one data type to another. You would get some of the bits truncated, therefore giving you the incorrect value. So be careful when you're typecasting, but this should be an easy way to get around the problem. So let's go ahead and save that. And we can rebuild here. Let's just do make again. And you can see this time it did detect that we made some changes. We added in that int typecast. And now we were successfully compiled without any warnings. So that's great. That's exactly what I wanted. So now that we've taken care of that, let's go ahead and move some code around. The first thing I want to do is I want to go into our make file. This is what actually compiles our code. And we have this source directory parameter. Let's go ahead and change this back to src, since we're not going to be working in the main simple list directory anymore. So if we just type in src and save this. Let's go ahead and try compiling once more, and we should see it fail now because the compiler will not know where your current main CPP file exists. So let's go ahead and do that real quick. Let's run make, nothing to be done for all. Yeah, that's because it's already made and we changed nothing. So make here, it says no input files. So it couldn't find main.cpp. Well, don't worry, we're just going to be moving it around a little bit in order to structure our program just a little better here and then introduce a class. And if you're new and stopping by to watch an episode today, please take a moment to subscribe below and hit the notification bell for upcoming programming tutorials and other videos on the channel. We'll go ahead and exit out of the make file after we've saved it. And let's go ahead and just move this main CPP file up to the source directory. And it's going to ask you, are you sure you want to move the main CPP file to the source directory? And I'm just going to hit move because I am certain. So now we have the main project file or directory. And then if you expand that, you have a few more directories underneath it. One's an object directory. So this is where things will be compiled, a source directory where we actually write our code into. So in the source directory, we have an includes folder or directory and a main CPP file. So let's go ahead and make sure that we can build our project still. We'll just do make again. And there you go. Now it recognized it and we have simple list generated. So let's make sure we can run simple list. So here we go. We just type in simple list. It says username not supplied, exiting the program just like we would expect. Great. And now since we went ahead and verified everything still works and can compile correctly after moving some stuff around, we're going to go ahead and exit out of the terminal. And let's go ahead and introduce a new file to our program. And where we're going to introduce this file is in the includes folder. So make sure to right click on the includes folder and hit new file. We're going to go ahead and call this list.h. So .h stands for a type of file extension known as a header file. And all that header files are just a place to really keep prototypes and definitions and some variables. That way you can kind of distinguish between your source code and definitions that you have for your source code. This is an older idea, and that's actually why it has this little c instead of a C++, because it was initially introduced in C instead of C++. And we're going to go ahead and use this to go ahead and define our class. So what is a class? A class is really a building block to object-oriented programming because it's a data type that's user-defined. And in this data type, you can go ahead and specify whatever types of variables and functions that you want to exist in them. So classes are really designed to help you organize your code better and make things look much cleaner, hopefully minimizing the time it takes someone else to look at your code and learn about it. You can technically get away without doing any type of object-oriented programming or introducing classes, but it would be very hard to follow your code, and especially when the code base gets very large. So in our list.h, how do we define a class? Well, we simply do it by typing in class and then putting braces. Now inside those braces, we get to define something called members. And all the members are functions and variables, just like we talked about before, but specifically inside of a class. So don't let members trip you up. It's just a function or variable like we've been using. So up here, after class, we want to define our class name. So we just type in list. I'm going to call this class a list. And inside of list, there are going to be our member functions and our member variables. So let's go ahead and define a few, but technically all of these already exist in our main CPP file. We just want to move them over. But before we do, there's three things we want to talk about, and these are called access specifiers. So we have the private one, the protected one, and the public one. So you shouldn't get too tripped up about what these are, and I'm missing a semicolon here at the bottom. So all that private means is it's an access specifier that says anything in this area underneath private will only belong to this class. So only the class itself can see anything that's defined in this space between private and protected. And it really doesn't matter what order you define these in, as long as you keep your statements in between the two. So here, anything defined in protected will mean that only the class itself, list, or anything that inherits the list class can access member functions and variables of this class. And then public, that means any classes or outside source files can access the members inside this class. So basically, if you want anything to access member variables and functions, you put it in public. If you don't want anything to access it, go ahead, put it in private. And if you want some things that are related to list to access them, you'll put them in protected, simply put. So we're just going to use public for now. I'm going to keep these blank, so I'm just going to put them together here. And then in the public section, let's go ahead back to main and copy a few things. The first things I want to copy are going to be the function prototypes that I defined before. So I'm going to go ahead and just do copy, go back over to list, paste it in here, just because I want to clean things up, move them out of there. Also, I know in the last video I wanted to go ahead and remove this argument from the print menu. We don't need to go ahead and pass in name. We'll go ahead and make that also a member variable in this class. So we're going to move that there, get rid of that. We'll also go ahead and move these two in. So let's go ahead, copy that, paste this as well into public. We'll make this as simple of a class as we can. And right now the IDE is complaining a little bit. It doesn't know what vector or string is, so we're going to have to include two things here. The IO stream functions of the standard library, and again include the vector functions of the standard library, just like we did in main up here. And we can also do the using namespace std, so we'll copy that over as well, right below. And then that means we can get rid of all of this. And you see how we're slowly cleaning things up here, although it looks a little messy right now because we've got red all over the place. Now let's just make sure that this all looks good, and I think it does. So I want to create one more new file here. Let's go ahead and in the source directory, create a new file. And this one's going to be called list.cpp. Go ahead and save that. And once we have our list.cpp file made in the source directory, we're going to go ahead and actually copy a few more things out of main. So really, all I want in main is my main function. I want to make it look as clean as possible. And I want to put all the relevant functions to my list class and or object into the list.cpp file. So all these functions here that we created before, called print menu, let's see what else, add item, delete item, and print list, we should move those. Let's go ahead, since they're part of our list, move them to list. So we'll just copy all of those functions. And once we got those copied, we can go ahead and delete them out. So only main is left here in our main CPP file, and move them over to the list CPP file. So go ahead, paste that in. And I bet you we get a little bit of complaining here that some stuff is missing. Yep, so it can't resolve cout, it can't resolve string, can't resolve a bunch of things here. But that's okay, because the IDE currently doesn't know what in the world a string is and all that fun stuff. So what we can actually do is include our header file, because our header file already has IOStream and vector and what namespace we're using, the standard namespace, and that will help resolve all of these things that are currently in red. So let's just do this, include, and we'll do quotes here. And now, where is list.h? Well, list.h in relation to the CPP file is in our include folder or directory. So let's go ahead and just do include. See, it's getting resolved here. It realizes that it's a folder. And then we'll do the backslash. And now it populates the list.h. So go ahead, put list.h in there. If we save this, you can see that a lot of the red here goes away, which is great. So one thing that we did earlier is we went ahead and removed an argument from print menu, at least in the prototype. So we actually have to do that with every single place we pass in an argument and where we'd actually define the function. So here, print menu string name will not match what's declared here. So let's go ahead and fix that. We'll remove this and save it. And then I'm just going to keep looking here for other places that might show up. Here. So we're passing in a name. Can't do that anymore. And again, we're passing in a name. We can't do that anymore. And once more here, we're passing in a name and we can't do that anymore. So once we got that fixed, should be good. Let's go ahead and go back here and talk about a few more things. There's also some functions that always come standard when you create a class, and those are the constructor and destructor. So these are special methods which are reserved whenever you create a class and will always follow the class name. So what do I mean by that? I mean, there's a function that's already predefined that is called list, and then you can go ahead and overwrite that function by creating one like this. And then there's another one with a tilde, just like this. So why are these two special? So this is actually a constructor, spell that right, and this is a destructor. A constructor gets executed whenever the object gets created. So whenever we define our object in our code and it gets called to go ahead and create that object, this constructor will always be called and things inside of here will be executed right away. So this is just really good for initializing values in your class if you need to do so. And then the destructor will get called whenever terminating the program in some fashion, let's say deleting an object, which we'll talk about at some other point, or going out of scope of where this class was created as an object. It's just some little tidbits to know about classes. We can keep them here with nothing in them. This is just notes right now. So if you ever need to make a note, you can just do 2 backslashes and then followed by your note. This will only be good for one line. And if you're in this far, go ahead and take a moment to hit the like button. It really does help me out. Let's go ahead and save this. And then let's go back to our list CPP. Well, right now we've included the list.h file. Everything looks okay, but there's one obvious thing that I see that's wrong. So right now, this print menu function, these are just functions that look like we've created, but they really don't know what they belong to, because we also have the same exact functions named in our class. Well, we need to tell the source file that we want these to belong to the class. And how do we do that? Well, that's really simple. We just go list, : and now list can correlate itself and say that, okay, I'm a class, I'm called list, I have these member functions, and now these member functions are going to be defined here. So much like we did prototypes before, here are basically our prototypes that exist to list, and here we're just correlating those two together by doing this list : and telling it, hey, I'm defined right here. So let's go ahead and do that to every function. We'll add it in here. We'll do list : and that's why the IDE was complaining there for a moment. And as you can see here, it doesn't know where it's going to get list from. Well, that's because it doesn't know it's part of the list class. So let's go ahead and do that there as well as here. And now we're in a really good place to go ahead and hit save. And I think we just have a little bit more cleanup to do, and I think we'll be done here. And we can look through our 3 files that we have now. And let's go real fast to main and check out what problems we have in there. Well, the first problem I see is it doesn't know what name is. And I remember that print menu did get name taken out of it, so I'm going to take it out of here as far as an argument goes. And it doesn't know what cout is anymore. Well, yeah, we removed the included functions from the standard library, so we got to include them again, or we can just go ahead and include list.h. And we want to include list.h because we want to include our new data type or class called list. So let's go ahead and do that. We'll just do that by doing include again. and we already know where this one's at, so it's in the include folder as list.h, and it should resolve most of these issues now. Wait a second, I messed that up. We don't want these angle brackets, we want quotes here, and now that should fix that. And you can see now it resolves string and the cout functions. So let's go ahead and change this up because it doesn't know what a name is. Well, what happened to name? Well, we moved it into a class. So this class here has a name, but how do we access that name inside the class? Well, we first have to create a new object. This is the first time we're going to be creating an object, and it's as simple as defining basically a data type and a variable. So all we have to do is type in list, and since we've included the list.h file, the compiler will know how to resolve a list as a class, and then we're going to go ahead and specify what we want to call that object. So we can just say, let's call it simple list. Why not? So now we have a simple list object of a list class. So what does a simple list look like? Well, it looks like everything that we've specified here in the header file. So it has a constructor, a deconstructor, which do nothing. Everything's under public. It has a vector called list, and it has a string called name. It has 4 functions, all that don't return anything. And how are those 4 functions defined? All in list.cpp. So we'll go back here. And then, so how do we access name inside of list.h? Well, we do simple list, and then we do a little dot. And now it knows that name exists in simple list because it's a object of class list. So we can also do that with print menu. So simple list dot print menu, and it should resolve. Everything looks good so far. Let's go ahead and save this. Let's try to run it now. Make sure that there's no problems. We've done quite a bit of cleanup at this point. So we'll just do the make command, and it looks like everything compiled. Notice that we do have another line added in here because we're actually compiling 2 objects now, the main CPP file and the list CPP file as an object. So you can see here you have your list CPP, main CPP, and then they're linked together. So let's go ahead and simply run simple list. And first let's do it without an argument just to test it, make sure that it tells us that a username is not supplied. And look at that, username not supplied, exiting the program. Great, so far so good. Let's go ahead and rerun our program, this time with a username. And looks like we got our menu again. Awesome. So let's go ahead and add a couple items to the list. So option 2, I'm going to add item 1. I'm going to add another one, item 2. And I want to print the list, so I'm going to go ahead and hit 1. And look at that, printing list. We have item 1, item 2. Let's go ahead and return to the menu by typing in uppercase M or lowercase m. Now let's just go ahead and quit out of our program with 4. And it looks like everything's working properly, just like it did before. But now we have the knowledge of classes, and let's look at why classes and object-oriented programming is so powerful. As you can tell, the main CPP source file is a lot smaller now, only with the main function. It looks very simple, easy to follow, and you can also recognize that in the list H and CPP file, we've now grouped things that are of a similar function. So it really makes sense to go ahead and put these all together alone by each other and separated from everything else in our program. We have a really nice user-defined class here, and this has really given us some great structure at this point. So I already have Git brought up here for installation purposes, and I also have a repo ready for our simple list program, so we can pull that down and see how everything integrates with Visual Studio Code. So there's actually a bunch of ways to use Git, but we'll go ahead and focus on using it through Visual Studio Code, since that's the IDE we're using to create our simple list program. So to first start out, we'll make sure to install Git. And I'm here on the Git website with some download information in front of me about how to get it for Linux or a Unix system. As you can see here below, we have all these different options. So if you have a Debian Ubuntu based system, we can simply get it by just applying this into a terminal. And specifically for Ubuntu, for having the latest stable Git version, we'd have to do this command. So depending on what system you're using, you can also install Fedora, Gentoo, Arch Linux, OpenSUSE, Mageia, Nix, FreeBSD, and a few more down here. That's just in case you're following along in some kind of a different Linux operating system. So let's go ahead and launch a terminal to make sure that we do have something installed. Let me make this a little bigger so you can see it better. And what I'll do is actually I'll just go ahead, since I have Ubuntu here, I'm going to go ahead and copy this line of code here and then execute it in the terminal. It says I must be root, and of course I do, so we want to add sudo in front of that. Paste that in. Again, I'll make sure to go ahead and leave this link in the description below so you can get to it. Go ahead and put your password in for administrative privileges. Give it a moment here. So I really didn't see it install anything, so I'm just going to do this manually here. So sudo apt-get update, since we pull down a specific repo, and then we'll just do apt install git. Make sure that we have that, and I forgot sudo in front of that. So sudo apt-get install git, and we can install it, so we will finish that install. Not sure why their command didn't work before, but as it says here, we just do apt-get install git, and that should get the git package for us on Ubuntu. Next, we'll go ahead and test it by just doing git, I believe, version here, and that's not a command because I'm missing one more dash, and now we can see we have git version 2.250. So this is really a prerequisite to go ahead and download Git in order to use it with Visual Studio Code, because Visual Studio Code does not come with it. Alright, so I'm on the GitHub repository page for Simple List, where I'm going to show you how to go ahead and clone the Simple List repository so you have it locally on your computer, and you can continue working on the Simple List project with me. Or if you haven't started already, you can clone it down as well and continue from the current episode. Make sure to take a moment and like the video if you've made it this far. It really does help me out. So after you have Git installed, you can go ahead and click on this link here. I'll make sure to go ahead and put this repo in the description below as well, so you can go ahead and get to it. And you really have two options. You can copy this right here, or you can download the zip file. The main difference here is this is just a manual way of doing it. I highly suggest doing it through terminal using git clone. It'll copy the repository over better. I've had issues in the past doing the download zip. So if we go ahead and copy this, we can go ahead and start a terminal up. And in terminal, all we have to do is navigate to the directory where we want to save the repository. So I'm just going to save it somewhere like, let's see, home, savvy Nick, and then I'll put it, let's see, I'll put it in on the desktop. So after I've navigated to my desktop, I'll go ahead and do git clone. So clone is a command that comes with git, which actually pulls down the repository to your local computer. So anytime you want to pull down a repository that uses git as its source control, you can use the git clone command and then paste in the repository's URL, which we just copied. Go ahead, press enter, and then you may or may not be asked for a username and password if it's the first time using git clone, or if a repository requires a user and password in order to go ahead and download the repository, you will be asked for those credentials. But mine doesn't, so it's all fine here. And I'm just going to list what's on the desktop, and you can see here we do have Simple List now. So let's navigate into Simple List, and let me just do it a graphical way. So I'm going to start up Files and just go to my desktop here, and you can see we have Simple List. And if I click on Simple List, you'll see a object folder, a source folder, a makefile, and a readme.md file, which is very similar to what we see here. Should be exactly the same actually. So object source makefile readme.md. So now we have the repo cloned locally to our computer. So let's go ahead and open up Visual Studio Code again and open up that workspace. So we can do that multiple ways, but let's just do actually open this up hit open folder. And if you got more than one opened up already, you can go through file and open folder as well. And I want to navigate to my desktop, so I'll go home and then hit the desktop location. And now I see simple list here. I'm going to double click on that and just hit OK. So Visual Studio Code will reload real quick, and now you can see that we have simple list here available as a project. What we're more concerned about is the source control, so let's go ahead and click on source control. And you can see here that there's no changes, but source control is Git, and it does recognize that your project has some form of source control using Git. So it automatically loaded some stuff in here for you. And what we can see here at the top, it says again source control Git, and then we can toggle our views depending on how we want either the folders displayed or just every single file displayed, and then a commit, as well as a few more options. We'll go through all that in a moment here. So let's go ahead and go back to Explorer. In order to track changes, we'll have to make a change. Right now there's no changes, so we don't see anything in our source control. So let's go ahead and make a change. I'm going to go into my source directory, and actually I want to make a change to list.cpp. So before we were working on this delete item function, and we sort of stubbed it out, but right now it has really no function. It just kind of lists out all the available items in our simple list to the user, but doesn't actually have the option of deleting it. So the first thing we want to do is, after we've asked them to go ahead and select an index number to delete, we'll go ahead, let me just delete this new line character, add a colon in and a space. That way, when the user enters in something in the terminal, it will show up on the same line as this message here. It'll just make it look a little cleaner. And then here in this blank space, we'll continue coding. So the first thing we want is an input from the user, and how we're going to do that is using sin again. And sin, we'll actually have to define some new variable here. Let's make it an integer, because it's going to be a number that they're going to choose from. And that integer, let's call it, choice num for choice number. And then we'll use sin in order to pass into choice number, the number that the user supplies to the terminal. After they press enter, we'll get that choice that they put in here in this choice number variable. So now we got to do something with this choice number variable, and that's delete an item from the list based on what number they had selected in a terminal. So in order to do that, we need access to our vector. Our vector is this list of items. So we'll do list dot. There's a function actually called erase with vectors. So you can see here, erase is available, and it comes with the standard vector, and we have a standard vector of strings that we created earlier. You can look at previous episodes in order to catch up on that and get an explanation for it as well. So erase is in a function, so I'll put the braces there, and then let me just put a semicolon in. And the reason it's complaining right now is it's saying, okay, you're going to use the function erase, but you haven't supplied any arguments to me yet. So what arguments are needed? Well, there's one that's what number you want to delete. So first we'll have to do another function, so list.begin, because currently we don't know where the vector list that we're keeping track of actually begins, and that's exactly what this function returns. It returns the location of the vector. And then we'll put a plus, and we'll just put our choice num. So what this effectively does is list begin will return where the list exists, and then we add choice number for whatever choice that the user selects to the beginning, effectively deleting the item that the user wants from the list with the use of the erase function of this object vector. So let's just go through this real quick. So if the user gave us a terminal input and the choice number was, let's say, 1, then the list, let's pretend it begins at some number 0. It would be 0 plus 1, meaning erase from the list 1 or the second location in the list, since our list began with 0. So if we run through it again, if the user gave us a 0 and the list began at 0 and their number choice was 0, it would erase the very first element, which is 0. Alright, after that's done, let's go ahead and just save it. And as you can see here, as soon as I saved it, I got this list CPP now kind of in a brownish color, and it says modified. Also, I got a little bubble here that says 1, and it's a pending change. So list CPP has changed, something has been modified. If we right click on here, we can look and do a couple things here. We can add it to a git ignore file, which we won't talk about today. But we can stage changes, discard changes, so if we want to get rid of the changes that we made, and even open changes. So let's go ahead and open changes so we can see them side by side. As you can see here in red, you can see stuff that we've deleted. In green, stuff that we've added. And we get a side-by-side comparison. The two results are what used to be there and what is there now. So this is a great way to look through code, compare it, and see what's been modified. And when a team of users is working on programming things together, source control becomes really the only way to keep track of everything in a proper manner. So now that I have these changes made, I'm going to go ahead and first test my changes. And then after I've tested them, if I'm convinced they work, I'll go ahead and push them to the GitHub repo online. So first thing I'm going to do is launch a new terminal here so I can do a make command and build my project again. Once I made the project, you can see that a bunch of files showed up here. It's because the compiler made some files, two object files as you can see here, and then another 2 files as well here, which have this U next to them, meaning untracked. So we're not keeping track of any of these files. They're all extra files and they get reproduced every single time you do make. So I don't want them in my main repo, so I'll keep them out. Next thing I'm going to do is run the program. So if I do .simple list and then put savvy Nick for a username, you can see here that we have print list, add to list, delete from list, or quit. I want to add a list. I'm going to add a item 1, and then I'm going to go ahead and add to the list again. I'm going to put item 2. I know, pretty original, isn't it? But it'll get the job done. And again, I'm going to put item 3. And I'm going to do option 1 to print our list. And you can see that there's an item 1, item 2, item 3. To get back to the menu, I type capital M or lowercase m because we provisioned for that. And then if I do 3, I'm going to delete from the list. Well, now I get 3 different items. So I can see now why I had the new line character, and I'll have to add that back in because you can see that item 0 actually lined up with this same line that we spit out to the user. So we don't want that. I'm going to actually do Control C to exit out of this program. I'm going to correct that right away. So I can see, let's go back to our list CPP file and just add back in this new line character. And that should fix things. I was trying to be fancy, but that didn't work out quite right for me. So again, I've made the change. I've saved it. I'm going to do make again, and that rebuilt my project. And then I'll run the simple list with Savvy Nick. I'll go ahead and add to the list item 1, and add to the list item 2, add to the list again item 3, and then I'm going to go ahead and print the list doing 1. You can see that I have item 1, item 2, item 3. Go back to menu and delete from the list. And now you can see putting that new line back in made it look a lot better. It says select an item, index number to delete. That's referencing this 0, 1, or 2. So let's say I want to delete item number 2. I'm just going to simply type in 1, press enter. Now I'm going to print my list again, so I'm going to do 1. As you can see, item number 2 is removed from our list, and we only have item 1 and item 3. So that function that we finished up seems to be working just fine. I'm going to go back into menu, and I'm just going to quit out of the program. Since I'm convinced it works, I am happy to go ahead and push those changes. Let's talk more in depth about that source control. Again, if we go to the source control here and we right click and do open changes, we can see the changes side by side. since I added this new line character back in, you can see that it doesn't have the red anymore and it looks perfectly fine. But you can see green here because I added just a little bit of code in order to erase an item from the list. We also have this modified M. So what we can do is actually do a commit. So right here it says, let me expand this a little bit, message. Control Enter to commit on master. So we can actually commit this change, and all commit means is it's going to package everything locally and get it ready to be sent to the GitHub repository that keeps a sync of all your changes. So in here we can actually put a message in. So let's say something so we can keep track of it. We'll say episode number 6, updating our delete function, and that's good enough for me. So I'm going to go ahead and just hit this checkbox, which is commit, and it's warning us that there's no stage changes. Well, just the fact that we've modified something doesn't mean that we're ready to go ahead and send those changes down, so we're going to actually have to hit stage changes here. So right click on the file, hit stage changes, and now we should be able to hit the checkbox. And you can see that those changes have been committed locally, but they have not been pushed to the outside world yet. So let's go ahead, go to Google Chrome. I'm just going to refresh this page to kind of show you. You see right here, it hasn't said anything about episode number 6 yet. In our source file, if we look at list CPP, we're not going to see the change that we've done yet to delete item. So the next step is to push the change. So the steps that we've kind of gone through is we made a change to a file. We went ahead and staged those changes, meaning we accepted them locally. Then we went ahead and made a commit. We just locally again said that we're accepting those changes locally. And finally, the last thing we need to do is push those changes. So I'm going to go ahead and hit push. And then it's asking me for a username, so SavvyNick is my user. And go ahead, put your password in. I got my password here. So I'm going to go ahead and hit enter. It's going to take a moment here. And you can see down in the bottom right, I got a what I like to install a extension and periodically run git fetch, which will just fetch any changes down. You can set this to yes or no or ask later. So I'm not going to worry about that right now. And at this point, we should have all our changes done. I'm just going to do a make clean just to clean out all the objects that were showing up here, just so I can show that we have all of our changes currently in sync. So what I can do is actually do a pull, and that will merge any changes that I have currently in Git back to my local repository. But since there is none and I have the master repository in front of me here, there aren't any changes to actually pull down. So if I go back to this GitHub repo and I do a refresh, you can see now that we have the 3 new lines added to our repository. And if we go back here, I can just look at the simple list main repo. And you can see in the source folder we have episode number 6 as our commit, updating our delete function. And that's really it, at least for the basic functions of Git Source Control. The plan today is to go ahead and set up a skeleton to be able to read and write out of a file, which will help us save our simple list to a file, much like a database, and then we'll be able to access that database file and make edits to our list in the future. So let's go ahead and jump in. The first thing we want to do is we want to go ahead and create a few new files. We'll go ahead and create them in the source directory first, and then one in the include directory as well. We're really just creating a new class, so first let's just do the one in include, and we'll call this one database.h. You can see a U popped up here because it's currently untracked with the Git repository, like we discussed in the last video. If you're unfamiliar with Git repos and you'd like to know how to use one, go ahead and check out the last video, episode 6, where I show you around using Git with Visual Studio Code. I'm going to go ahead and use databases.h just like I did with list.h and create a class. So I'm going to go ahead and just copy everything over because we will be reusing much of this in our database.h file. So let's go go ahead and paste this in. I will be using the IOStream library as well as the vector library, and we'll be using two more libraries in here in a moment. But let's go ahead and define our class. First, we're going to rename this class, and let's name it database, since we're going to go ahead and consider this our database. So we have the class, and the class name is database. And then below, we need to go ahead and create our constructor and deconstructor. So they're just going to have the same name as the class. So again, database, and then we got the tilde with the database, which signifies our destructor. All right, now that we got those two stubbed out, we're not going to need any of these defined functions, which we already created for list CPP. Instead, we're going to go ahead and delete those and create two other functions. I'm going to do void because it's not going to return anything. One function called write, and currently I'm not going to pass any parameters into it. And then I'm going to do another function called read. So as you can guess, write's going to write to a file and read's going to read out of that file. I'm going to keep vector string list here and string name just in case we have to use it later as member variables. I'll also add a protected variable a little later, but for now we're going to wait, and I'm just going to make saves to anything that I've worked on. I don't think I've actually done anything in this file. I'm not sure why it has a little dot here on list CPP, but I'll take a look here in a moment. Actually, I'm just going to create a save for now, and then if I get an error, I'll go ahead and take care of that later. So back to database.h. So now we've kind of stubbed out our class that we want to use. The next thing we need to do is create the CPP where all these functions will exist, the write and the read. So let's go ahead and do that. I'm going to collapse the include folder and then add a new file called database CPP to match our header file. Next, I'm going to go ahead and do what I did here and include database H in the database CPP file. So we're going to go ahead, go back here, and let's just do include, and then we'll put these parentheses, and inside those parentheses we're going to go ahead and point to our include folder, so include, and as you can see it automatically populated for me, but database H is what I need. So below that, I can go ahead and create my write and read functions. So the first one I'm going to make is the write function, since we'll have to create a file in order to read back in the file, so that one makes the most sense. And since this is a class function, I'm going to have to define what class it's for. So we included the database class, and we're defining this function for that class, so I put the database followed by 2 colons. And you can see here that we have access to read and write. Write is the one we want to create, and currently there are no arguments. So let's go ahead and put some curly braces. And the one thing I forgot is to put in front the return type. So it's not returning anything, therefore we can put void up here in front, just like we had done in the database H file, as you see down here. And then all our errors are cleaned up now. So in order to write, we're going to have to open up a file, and we're going to have to take advantage of another C++ standard library. In order to include that library, we're going to have to go back to database.h and include it. So we're going to type include. And since it's a library that's normally included in the system environmental variables path, it'll automatically be able to be pulled in here. We can include it by doing angle brackets and including fstream. Let's go ahead and save this and then go back to database.cpp. In the write function, we should be able to now access functions from that fstream library. And really two important ones, ofstream and ifstream, for output file stream and input file stream. That way you kind of understand what they mean. Output file stream allows you to write out to a file, and input file stream allows you to read in from a file. So since we're writing, we're going to use ofstream. So we go ofstream, and then we can just define a variable of type ofstream. So I'm just going to call it db. So now db is of type ofstream. As you see here, it says from the standard library ofstream is db. So now let's go ahead and create a new line to go ahead and open up a file. So how do we do that? There's a ton of functions here that we can use with ofstream. So I'm going to use the open function. And right now open is complaining a little bit because we haven't supplied what we want to open. So I'm actually going to be creating a new folder, db, and I'm just going to call it lists or lists.sl for simple list. Don't get too tripped up on the .sl. That's just a file extension that I'm creating for only the purposes of the simple list. It doesn't really exist, but you can use whatever you want, so I just chose to use SL. Alright, that should open a file, and then db close, we'll make sure to close that file after everything is said and done. In between the open and close, we'll go ahead and write a few more statements in order to just throw something into the file. But before I do that, I'm going to go ahead and create my DB directory. So I'm going to make a save to that. Then let's just go ahead and hit this new folder and create DB. That way, whenever we open up a file in DB, we'll see it right here. All right, now that we are opening the file, let's go ahead and focus on writing something to the file. We'll first want to make sure that the actual file is open. So let's do an if statement. If the DB is, there's an is open. So this function here is created in order to tell us if a file is open. So it simply returns a Boolean, a 0 or a 1, if a file is open successfully or not. So we're going to go ahead and use that function. And if our file is open, we'll do something in these curly braces here. Else, we'll do something else in these other curly braces right here. So let's focus on if it is open. We can actually take advantage of the DB object and just push information into it, very much like we do with cout. If you remember, with the cout object, you can go ahead and just do cout and then type in some type of a string here between two quotes. What I'm going to do is the same here. So whatever I put on this side will go into this database object of type OFStream. Let me just do something simple like 1, 2, new line, 3, new line. So what I'm doing here is I'm typing a 1 and then a new line character. So we start a new line, 2, start a new line, 3, start a new line, and hopefully this will be in our file as well. So I'm just going to go up to 5 and that should be enough for me. I'm going to put a semicolon at the end and make another line. And really, I think that's enough. Let's go ahead and just use that to test with for now. And I'm going to go ahead and create a save here. And then in else, I'm just going to use the cout object. So I'm going to go ahead and print something out into the terminal for the user and just tell them if I can't open the file. So all I'm going to say is cannot open file for writing. And there we go. That's just in case our program doesn't have permissions for the folder where the program is located. Then we might not be able to open it up, or if it's already opened by something else, we might not be able to open it up. It's nice to have a little bit of error handling here and let us know, hey, you can't open up the file. So I'm going to save that. And I think that's enough for now. Let's go ahead and see if we can't compile this real quick. So I'm just going to go ahead and open up a terminal. Hit that new terminal button here at the bottom, and since I'm already in the simplest directory, I'm just going to print this out. I'm going to use the make command to go ahead and build our project. So we do make, and you can see everything successfully was made. That's a great thing. And it even created our database object file from source database CPP. So everything looks correct there, but the one thing we're missing is actually calling this write function. So in the main CPP file, we're going to go ahead and add a call so we can go ahead and actually write to a file. So where do we want to do this? Let me think. So if we pass in an argument currently, we're going to go ahead and store that argument into simplest name and then run the print menu function. So for testing purposes, let's go ahead and put this new database class and instantiate it below. So we can just go ahead and not supply a username and then it'll just run the write function. So we can do this by first including up top the, include inside my include folder, the database H file. I'm going to save that. And then I can go ahead and do a very similar thing to this, call my create a new object and will be of type database. Since that now exists, as you can see, it's in green now. It says it's a class. And my object name, I'm just going to call it data for now. So since I've went ahead and instantiated that data object, I'm going to go ahead and now be able to call it. So now data, I can just call write. And since that's a function, I need these parentheses here. And this should be able to write to a file. And what's it going to write? We're going to go back to database CPP. It's going to write 1, 2, 3, 4, 5, all on their own line. So let's go ahead and give this a shot. I'm going to save main and do a build again. So make it. Let's see here. Can't really see this. Let me see if I just do a clear. And if you do make clean first, that erases all the objects. Clear again. I'm going to make it. and everything successfully built, as you can see. So I'm just going to run simple list, but instead of running with a username, I'm just going to go ahead and leave that out in order for us to be able to run this little portion of code and skip over this if statement. So we're going to go ahead and do that. It told us that the username was not supplied, exiting the program, just like we expect. It went through this else statement, but then it had to finish up these few lines here before it returned nothing. All right, so if everything went correctly, we should have a new file. And it did not, because it says cannot open file for writing. So it's a great thing that we added that in. Let's go back to database CBP and see if we can't find a problem. The one thing I do want to add is a new line character right here. That way it doesn't show up on the exact same line as my terminal output after the program is exited. I'll save this, but I don't see anything obvious here. We used the correct library OF stream, and then we did an open, and for whatever reason it did not open. So my guess is it's a permissions issue with the DB folder. So what I'm going to do is I'm just going to list everything with ls that I have in the current file and look for my DB folder. So I don't have a DB folder in here. And if I'm looking at this correctly, I think I created it in the wrong spot. Instead of the source folder, it should have been outside the source folder. So I'm going to go ahead and move this folder out into the main directory. So it says, do I want to move it into the main directory? Yes, I do. And now I see DB up here, so that's great. I'm going to go ahead and recompile since I made that new line change. So first let me just clear this out so you can see it, and then I'm going to do another make. And let's run simple list one more time with no username. It said username not supplied, exiting the program. No error this time, so that's great. Now if I look into the DB folder, I see lists.sl. Great. So let's go ahead and open this up, and this looks great. We have 1, 2, 3, 4, 5 written into a new file called lists.sl. That's exactly what we wanted. If you're new and stopping by to watch a programming episode today, make sure to go ahead and subscribe and hit the notification bell for future videos. All right, great job if you've made it this far. Let's go ahead and exit out of our list.sl and we'll continue programming. So now that we've written to a file, why not read out of that file as well? So what I'm going to do is let me just close out of this terminal here. My view got a little bit jacked up here, but no big deal. Let me go back into the full screen mode. All right, that looks better. So now I'm going to go ahead and focus on creating my read function. So again, it's going to be a void, not returning anything. Database, since it belongs to the database class, we're going to call this one read. Let's go ahead and put some curly braces. And in here, we're going to do very much a similar thing to what we did before, except we're going to use ifstream for input file stream. We can call it DB again since it's only in the scope of read, just like ofstream DB was only in the scope of the write function. We're going to do db.open just like we did before, and the same place as well because we want to open up the file that we wrote to. Following that, we'll do a similar check. So if the DB is open, let's go ahead and do something. Else, if it's not, let's go ahead and tell them that it's not. So we cannot open file for reading. Dot, and then the new line character. Great. In here, let's go ahead and take advantage of a while loop with the getLine function. If we use while, this is a special operator that you can use in order to keep executing a condition until whatever's in these parentheses is not true anymore. So there's a special function we'll use inside these parentheses. It's called getLine. So getLine requires 3 arguments. The first argument is going to be our ifstream DB variable. Then the second one is going to be a string. We'll call it line. And the third one is another string, but it's the delimiting character. So since we end everything with a new line, just like we did up here, so 1 new line, 2 new line, 3 new line, 4 new line, 5 new line, we're expecting a new line in order to stop getting a line. So what this function will do is, while DB is open, we'll go through the DB, which is an input file stream, and look through that stream of characters and pass them into line every time we see a new line. And we'll repeat this process until we are done. Because of the while loop, we'll go through the entire document until getLine cannot return anything else. And right now it's complaining about line because we haven't defined it yet, so let's go ahead and do that up here. Let's just create a string called line, and now it shouldn't complain anymore. For some reason it looks like it cannot find getLine, but let's go ahead and continue writing here, and then we'll go ahead and take a look at what's wrong. All I want to do out is print out any character that I get inside of line and end this with a new line character. So all that's going to happen here is we're going to print out to the terminal anything that's returned to line from the DB and keep printing it out. Finally, we want to make sure, like before, we close out the DB once we're finished with it, or else we could have issues keeping it open. Let's go ahead and save this. So what I'm thinking is Visual Studio Code cannot find anything to use called getLine that has 3 arguments in it, and I think my problem isn't the fact that I have 3 arguments. It is actually this last argument. It cannot be a string. It has to be a character. And look at that. So now that I've specified it as a character with single quotation marks for the new line, that defines a character. And then when you do double quotes here, just like I did below, that defines a string. So this is a string and this is a character definition. So you'll want to make sure that you understand the difference between the two. A character just represents one unique alphanumeric, and a string can define a bunch of characters together. So a string can be thought of as a character array. Alright, so let's go ahead and save this, and I think this is enough to go ahead and run. The one thing we'll have to do, just like we did before, so let's go ahead and call the read function. So data read, semicolon at the end here, save that. Let's try compiling it. So I'm going to go ahead and launch my terminal. If you're in full screen, you can just hit Alt. That should bring this back up, and then hit the new terminal. And I like to make clean before I build. So I'm going to go ahead and build, and now run simple list without any argument and see what I get out of it. Awesome. Looks like we got just what we expected. So we launched simple list. It told us that the username wasn't supplied and it was going to exit the program. But before exiting the program, if we look at main, it called data write and data read. So the write wrote out the list.sl file and put in 1, 2, 3, 4, 5. Let's just take a look real quick. So 1, 2, 3, 4, 5. And then we read that. Please hit the like button. It really does help me out. So here comes the more exciting part. Let's go ahead and get our actual items list to be written out to the file, the list.sl file. So let me just go ahead and again exit out of this terminal, and let me just go back into the full screen. Alright, I'm going to go ahead and exit out of my list file, and really I'm just going to have to use main CPP and the database CPP file for the most part. Alright, I'm going to go to the databases H. I'm going to get rid of this line here for protected. We'll probably do this at a later date. I won't worry about this right now. The one thing I need to do is we need to be able to pass in the list that we've created in our other class so we can write it out to the file. In order to do this, we have to be able to pass in a vector string list, just like we have here. So let's go ahead and paste that in as an argument. And if we do this here, we have to make sure to get rid of this semicolon and do the exact same thing inside our database CPP file. So here, write isn't matching the one that's in the header file anymore, so our prototype. So we must match it. Let's go ahead and save both. Control S. And now you can see that that's all good. So again, why do we want this list? Well, we want to get the list from our simple list. So we're also going to have to move up some of these items. So I'm going to actually remove list out of the scope of just this if statement, and I'm going to pull it up so that it shows up up top and is readable by everything. I'm going to do the same with the database object. So put that up here, get rid of it. We don't need to define it twice. I'm going to get rid of it here as well. And now I'm going to call the data write function here instead. And now I can pass in, as you see, a standard vector of standard strings, and it's called a list. So what is that list? Well, it's simple list because that's the object that we're going to go ahead and pass in, but something very specific from simple list. So let's go ahead and put the dot. We want to pass in our list. So there we go. Those should match up, and they do. So anything that's saved and created in our simple list object that's located in our list will be passed into the data write function, and then we'll have access to the simple list inside our database write function. Finally, we're just going to do a data read to read it back to us. And let's get rid of this because we don't need that anymore since we're calling them above. So this time we're going to go ahead and have to supply at least one argument in order to get into this if statement and do a write and a read. So this time we'll supply our username, but before we do that, we need to go ahead and actually print out the values. So instead of using this and just printing out these 1, 2, 3, 4, 5s with new lines, we're going to put our own list vector inside. So how do we do this? We're going to have to add a for loop. Actually, we already have this done. So let me just go ahead and delete this and grab it from a different function. It's going to be in our list CPP file. If we go down, let's keep scrolling, we should have a print list, and we do. So if we can print the list and we iterate through the whole entire vector of items, we can do the same in our database CPP file. So if it's open, let's go ahead and iterate through every single index. Let me see if I can. It's becoming a little hard to see here. So what I'm going to do is actually move this out of the way so we can see the entirety of the code and go back into the full screen. So let's go through this real quick. We have this for loop. Let's make sure to indent things so we can see how they all go with each other. So this for loop, this is the ending brace for that for loop. We're defining an integer called list index, and we start at 0. If list index is smaller than the list size, which is a cast of integer, then we increment our list index by 1 every single time we complete the for loop. So all that does for us is it starts at 0, increments the index. That way we can reach all of the elements inside of our vector and spit it out to the screen. Well, we don't want to spit it out to the screen anymore. Instead, I'm going to go ahead and get rid of this. And instead of cout, we're going to put db here. So this should effectively store all of our list items one by one into the database file with a new line character at the end. So let's go ahead and save this. Next, I want to go ahead and run a terminal. So I'm going to create a terminal and make clean. Clear the screen out once more, and let me go ahead and actually run it from here because it's going to be easier to see. The first thing is I have to supply a username this time, so Savvy Nick, and it's asking us to go ahead and print the list, add to the list, delete from the list, or quit. Currently we don't have anything in the list, so I'm going to add a couple items. So the first item I'm going to add in, I'm going to be original here and just do item 1. Then I'm going to press the option 2, item 2, option 2, item 3. Let me go ahead and print that list. So 1, I see item 1, item 2, item 3. I'm going to go ahead and hit the menu. And following that, I'm going to go ahead and quit from the list. Something didn't go right here. We didn't actually get our items printed back to us, which I'm pretty sure I know why. So I'm going to go ahead and exit out of this and go back to main. So before we call write or read, we go into simple list print menu. So let's go ahead and check that out. So that's in list CPP, and then we'll go down to the print menu function. So where was that? Here it is, print menu, our very first function. If we choose choice 4, we actually exit out of the program with a 0 return. So we don't want to do this anymore because this completely exits out of the program, meaning we're not going to actually execute these last couple lines here. Instead, we're just going to return 0 and completely exit out of this whole entire if statement. So let's go ahead and change that up a little bit. So instead of exiting, let's just do a return. And since this is actually a function that doesn't return anything, we don't actually have to return anything. We can just use the word return, and that should be enough for us. So let's go ahead and save this. Let's build it once more using our terminal, and let me just put in make clean and make. You don't really have to do make clean unless you change a header file out, but I like to do it anyway. It's not a big program, therefore it doesn't take long to compile, so it's very easy to do, but you can just run make. Doing simple list with Savvy Nick again. And I'm going to go ahead and add to my list, so 2, item 1, 2, item 2, 2, item 3, print my list with 1, go back to the main menu, and finally I'm going to quit out and see what I get. And here we go. We got our item 1, item 2, item 3 returned to us in the terminal, which is a great thing to see. We didn't get any errors. So these 3 presumably came from the new database file that we created. So let's go ahead and check that database file out. It's called lists.sl, and look at this. We have item 1, item 2, and item 3. So I'm going to be continuing off of what we had last. All right, and to start off, I want to go ahead and go to the database CPP file. So I'm going to go there instead and focus on this read function first. So last time we wrote a read and write function and created this database class, but today I'm going to be expanding on this read function in order to read in a file with a certain reading scheme that we're going to create. So we have the database list.sl file, so I'm going to go open that up. Right now we only have 3 items which we saved from the last video. I'm going to erase these, and we're going to actually create a little bit of our own format here so we can go ahead and program our code to go ahead and parse through and read through this formatted file. So the way I'm going to do this is anything with a hashtag in front of it will be considered a user. So we have hashtag, which means it's a user, and then we have SavvyNick, which is the username. Following that, we're going to have SavvyNick's list. So I'm just going to put some items in here. So item 1, item 2, item 3, item 4, and so on and so forth. Following that, we need something telling the code that SavvyNick's list is completed and finished. So I'm just going to go ahead and put a percentage sign. That'll be our delimiter for this project, and a list of items. So all that this means, I kind of just made this up. So again, hashtag means a username. So the username is SavvyNick. And then SavvyNick has a list of items, and those list of items are item 1, item 2, item 3, item 4. So a new line character will mean a new item in the list, but you can't see the new line, but it just is an inner. But it does exist. Our process will be able to see that these 2 are 2 distinct items in our list, as well as 3 and 4. In order to continue, I might as well add another user so we can test properly. And I'm going to call him Savvy, let's see, Bob. And Bob is going to have a few more items. So I'm going to say Bob has item 5, item 6, item 7, and that should be enough for Bob. And again, I'm going to close Bob's list by using a percentage sign. So now I have 2 users with 2 different lists in our database list.sl file. I'm going to go ahead and save this. And now let's work on parsing through this list. So currently, our database CPP file, the read function, is incapable of actually reading in that list. It's just going to go line by line through everything and spit out the line currently that's available in the file. So every time it sees a new line character, it's just going to spit out a line, which isn't really helpful since we have defined a few new items such as the username and the end of a list character. So I'm going to go back here, and let's go ahead and make some edits here for this read database function in order for us to be able to use the new list format. So in this while loop, I'm going to make a little bit of a change. And what I want to do is first detect whether or not I have a hashtag to define that a user has, to define that the list has a user. So I'm going to do an if statement in here and make sure to read in the line string. And what I'm interested here is a front function, which is just going to return the very first character in the string. And if that character is equal to a hashtag, then I want to go ahead and do something. Otherwise, if the same kind of deal, so line.front is equal to a percentage sign, then I want to do something else. So we got this if, else if statement, and we're checking for two different types of characters here. Finally, if nothing else, we'll go ahead and execute this line of code. And we'll just say something in here in a moment so we can keep track of things. So back to our first part of the if statement here. I just want to spit out whatever we find in here. This is for debugging purposes. So I'm going to do cout and just say that I found a hashtag. And then I'm just going to spit out the line where the hashtag was found. Again, this isn't really necessary for the program, but it makes for nice debugging purposes so we can tell what's happening while we're reading in our database file. Next, I want to go ahead and erase the very first character that is returned by the line string. So we can do that by using a function. So again, string has multiple functions. One is called erase, and what the erase function needs is just where to begin erasing the string from. So we can also take advantage of another function that tells us where the string begins, which is begin. And that's really all we need to supply to this function. It will automatically assume that we want to erase the very first character since we didn't specify how many we wanted to erase. So that should be good enough for us. And that's because I don't want to keep this hashtag in once I'm reading in usernames. So that's why I'm going to add that line of code. So it erases this hashtag while we save the list into our program. Following that, I want to define a new list here. So let's see. Let's make another vector of type string called user list. So this user list will just keep track of our list for each user as we're processing it in this read function. I'm going to use that new user list vector in order to push back the information that we just found, which is line. So just to walk through this real quick, if we do find a hashtag, we'll say that we found a hashtag and spit out the line where we found it. Then we'll erase the very first character and then add it to user list so we can keep track of that user's current list that's being processed. Following that, I'm going to complete the else statement. So this up here was just to find the username. Next, we'll want to find all the items that the user is supplying. So I'm just going to do cout again for debugging purposes. Found a item. And let me just put a space here so it looks a little better. And then I'm going to go ahead again, spit out line, and put a new line character at the end so it makes for a little better formatting there. Following that, again, I'm going to use the user list that we just created to push back line. So anytime we don't find a hashtag or we don't find a percentage sign, we're just going to assume it's an item in our list for the current user and push that back into the list. Let's go ahead and make a save right now. All right, and to do this next portion, we're going to have to make a little bit of edit to our database.h file to include a 2D vector that will help us keep track of our user as well as the list from the user. So I'm going to open up database.h. All right, and currently we have this vector string called list, but I want to go ahead and change this up so that it's actually a two-dimensional vector of strings. The way I'm going to do that is I'm going to add another vector here and just close it off with some angle brackets, and that will generate this vector of vector strings. I'm also going to rename my list here. I'm just going to call it main list. And since I'm doing that, I'm going to go ahead and change it here as well, main list. Maybe for the future when we use that. And I'm going to hit save. And following that, I also want to do a return type. So our read function should return something. So currently we're returning nothing. It's a void. So all that means is the function won't return any kind of value. Whereas now I do want to return something, and it's going to be a vector of vector strings. So in order to get your head around a vector of vector strings, just think of it as each individual user having their own list. So like Savvy Nick has his own list. That will be the first main vector. And then the second portion will be the list that Savvy Nick has. So I think you'll understand this a little bit more once we get into creating the code to store all of our items into the 2D vector. So we'll go ahead and move on and go back to database CPP. And down here, we can now work on our line front equaling the %sign. So let's go ahead and add another line of code. This one again, for debugging purposes, let's just say that we found a percentage. And then we'll just spit out what we found and a new line character. So if we do get a percentage, we'll print out the percentage and put this in front of it, found a percentage, just so we can keep track of things again. And what we'll want to do here is just go ahead and close off our list. So as we're going through things, if we get to a percentage sign, we know that our list has ended. And finally, since we're keeping track of a user list locally in read, we'll want to go ahead and pass this user list into the main list. So how can we do that? Well, since we have a two-dimensional vector, we can do it by passing our vector into the two-dimensional vector. So we do it much like we did down here. We use the pushback function, and now instead of pushing back just a string, we can push back an entire vector that we can keep track of. So that vector is the user list. And there we go, simple as that. Following that, let's just make sure to go ahead and clear out the contents of the user list. We can do that by using the clear function inside of the user list vector. And this will just clear everything in the vector. That way we can reuse it multiple times because we may or may not have multiple users. And up here, we're getting an incompatibility issue. It's because our database read function does not match the prototype in database H. So let's just copy this here. So you can see it's defined as a return type of vector strings. So we need to also copy this and paste it in front of our function so that the two match. So after we do this and save, you can see that read becomes compatible again. And since we are returning something, we need to make sure that at the end of our function, we do return the type that we specified we will return. And that is the main list, which is a 2D vector of strings. All right, and everything looks like it's currently happy, so great. If you went ahead and made it this far, please hit the like button. It really does help me out. And I think we're at a point where we can go ahead and test this program to see if we're actually parsing through things properly. So let's go ahead and go to our main CPP file and make sure that we call the read function. So what I want to do is I'm going to call the read function before anything here. That way we can tell whether or not our data is coming in properly right from the start. So I'm just moving basically this data.read up to the top here. So if we supply an argument, which is a username, we'll read in our data, which I think it actually makes more sense to do it after the simple list.name because we want the name of the user before we go ahead and read in a file. It'll help us down the road, and I'll go ahead and launch a new terminal. And let's go ahead and type in make so we can build our file. It looks like things compiled properly, so that's great. Now let's just go ahead and run the program. So we got simple list, and I'm going to type in our user Savvy Nick. As we would expect, we got multiple hashtags and percentage signs as well as items. So let's look back at here in our database CPP function so we can see what happened. So it did find a hashtag Savvy Nick, which is in our list, right? So it pulled that in, then item 1, item 2, item 3, item 4, and it saw the percentage sign. Then it got the next user, Savvy Bob, item 5, item 6, item 7, and the percentage sign. So it looks like everything populated in properly, and the only way it would have done that is to go through these 3 clauses here, the if, else if, and the else clause. So it looks like our program is executing properly, which is great, and we get our menu to either add to a list, print the list, etc., which we currently can't use because we're really not doing anything with this list of items. So I'm just going to go ahead and quit out of the program and then continue writing the code here. Next, I want to make a little bit of a change in the database CPP file again, but this time to the write function. I'm going to call this main list again, and this is also going to expect a vector that's a 2D vector. So now instead of just passing in a vector of strings, we're passing in a vector of vector strings. So let me also update the prototype, which is in database.h. This over and change this around. So now we have a matching prototype and a matching function definition. So following that, since main list doesn't exist, we'll see this little mistake here, and as well as here. So we'll just change those around to match, and everything should be okay at the moment. Now it's complaining here because we do have a problem. Since it's a 2D array, we're not properly addressing the string inside the vector. So what we'll do is we'll have to make a little bit of a change here in our for loop, because we'll have to keep track of the user as well as the items for the user in our vector, since it's a two-dimensional vector. So let's just go ahead and use what we currently have here and make some changes. So what I'll do is I'll go ahead and just erase all of this, and we'll start from scratch here. First, let's define an integer user index to keep track of our user, and we'll set that equal to 0. Following that, we want to make sure that the user index doesn't exceed the size of our main list vector object. So main list, and then we can put in the user index and the current size of whatever user vector that we're currently on. Finally, we'll want to increment the user index every time through the loop. So all this is doing here, this first main loop, I'll delete this statement here so we can follow this a little better, is the user index will start at 0. And as long as the user index is less than the size of the current user's vector list, then we'll go ahead and go through the user index. Next, we'll do a second for loop. So let's just do for int list index, so we can iterate through each individual user's list. We'll do list index less than int, very similar to what we had before, but we're addressing the second vector into two-dimensional vector. So user index and list index. And we want the size of that so we don't exceed it. And we'll just increment list index every time we spit out a list item. So again, the first for loop is to just go through the users, and the second is to go through the list of items for each user. That's why we have the two for loops. And let me just close the braces there. Finally, let's just go ahead and write to our database object the main list user index list index. So that just means the current item that we're on, and put a new line character at the end, just so we can read it a little easier. So again, we're printing each string that we have to our database so we can write later. We'll work on this actually in a different video. I'm just getting it set up for now. I might actually have an issue here now that I'm thinking about it, but we'll move on. It's not important. Everything will compile since we don't currently have any errors, but we'll look into this in a different video. Back to read. What I'm going to really focus on is being able to read things in. So we're getting close, but we have to make a little bit of a change in our list.cpp file. What I want to do is actually add a new function. So I'm going to go ahead and copy one from above and just press enter a couple times and add in a new function. I'm going to call this one find underscore user list. What this function will do, and I'm going to go ahead and delete everything inside of it right now, is scroll through the vectors and find a user, and then just tell us that that user has been found if they do exist in the main list two-dimensional array. So if it exists inside this main list, which is being returned. First, let's go ahead and make our prototype inside the list class. So we'll have to open up list.h, and let's go ahead and add it right here underneath without the colons or list here, because it knows it belongs to this class list, so we don't need to specify that again. Hit save and then go back to list CPP. This should clear up, and it does. Next we'll say bool, for boolean, user find equals false. This is just to keep track of whether we found a user or not. So just to keep things pretty, I'm just going to go ahead and copy these two statements and put them down here, and then change this to something like welcome. And then spit out a name, and that should be enough. That way we just know who is the current user, and we're welcoming them to the program and seeing if we can't find them in the list. So I'll hit save. Where does this name come from? Well, if you look at database.h, we have a string name which comes from main CPP. It says the first argument that we supply in a terminal is going to go into simplest name. So that's how we have that. Back to list CPP. We'll go down and create a couple more statements. Let's go ahead. We'll need another for loop here. We'll do int user index equal to 0 if the user index is less than a cast of an integer. Main list dot size, then we'll increment the user index and keep the for loop going. We're just starting the index at 0 and then making sure that the index isn't greater than the main list complete size of the vector. As long as it's not, we'll go through this for loop and increment the user index, so all the statements inside of here will be executed every time the user index increments until it reaches the size of the vector that we have supplied. So main list is currently not supplied in the list.cpp, so we'll have to go ahead and make an edit here in the list.h. So let's go ahead and keep this vector string called list and make a new one. So this is going to be another two-dimensional vector, so we'll have the vector of vector string, and we'll call this the main list. So this is really just think of it for a single user, and think of this as all the users and all the lists. And I'm just missing another angle bracket here, and then that should be good. Save that and go back to list CPP, and now this is resolved here. As we're going through the list, let's go ahead and make sure we print out our users here. So main list, user index, so underscore index. And then we want the very first element every time, because the very first element is guaranteed based off of our database to be the user with the way we have it set up. And we'll go ahead and put a new line character so we can just see things a little bit easier. Following that, we want an if statement. If our main list contains a user equal to the username supplied, then we want to do something, because that's what this function is meant for, find user list. So we'll search for the user's index in the very first position of our second vector. And if that equals equal to a name, which was supplied by the terminal, then we know we have a match. And we can say cout user has been found. And let's go ahead and spit out that main list username. So the current user index at the very first element in the second vector. We'll just do a new line character for formatting purposes. And then the really nice part is we can just say our current list is then equal to our main list user index. Let's go ahead and just say that the user was then also found. So this is true now. and break out of this for loop. And I misspelled this up here. It's supposed to be user found, not user find. We might also want to return this value type later out of the function, but for now I'm just going to keep it the way it is. And I'm missing a semicolon right here. And then I'm going to go ahead and save that. So let's go through this function real quick. What we're doing is we are incrementing over our entire main list, which is a two-dimensional vector. The first portion is to keep track of a list with multiple items inside of it. And then the second one is to keep track of each individual item. So we'll increment over the very first vector, and that technically is the user. So every time we find a new user, we'll go ahead and spit it out here. And then if we found that the current name supplied by the command is equal to whatever we're currently on, then we spit out, hey, we found that user, their name is this, and then we save the vector that contains our list into list. We also say that the user has been found, so we set that to true, and then we break out of this, for loop. So let's go ahead and save this. And at this point, I think we can go ahead and run the program once more and see if we get the results that we expect. The one thing we'll have to do is call the find user list function in main. So let's go ahead and do that. So we can do simple list dot find user list. We don't have to supply anything because we supplied it up top here, the name anyway. So what we'll do here is we'll take the name that's given to us from the terminal. We'll read data in based off that name. Then we'll go ahead and search through our vector. Then we'll search through our two-dimensional vector to try finding the username. And if we do find the username, we'll go ahead and save that user's list into another copy of the list, which is located in list.h. So basically, this is a two-dimensional vector. This is a one-dimensional vector. This one has our usernames and our lists for each username. And this one only contains a list. So we take and find, if we have a username, move their list into this one-dimensional array called list, because that's the current person using the program. So hopefully you understand that. It is a little complicated, but let's go ahead and run the program and see what result we get. So I'm going to open up another terminal here. And then I'm going to do a make in order to build a project. We get a little bit of a warning here. We didn't really use the user found variable, but that's fine. We'll use it at a different time. Let's go ahead. It's just a warning, not an error. So continue on. And I'm just going to supply simple list with Savvy Nick as the user. And let's scroll up a little bit just to make sure that we get some of the debug statements that we would expect. So we found a hashtag, Savvy Nick, found an item, all that good stuff. Great. It says here, welcome Savvy Nick. So we know that our function was called find user list. So let's go back into that. So we at least made it to here. But we do have a problem here because we did not find a user. So it says user has been found if we did find a user, but it doesn't look like we did find a user. So there is something wrong. So give me a few moments to go ahead and look through the code. Let me try one more thing and clear out the screen here. So I'm going to go first make clean, and then I'm going to remake the project. And after that, I'm going to run Savvy Nick again just to make sure that I did compile the header files, and I did. So still not getting it. And I do know why, because I forgot something in main. So main CPP, we say that we're going to get simplelist.name, and we get an argument of the name, and then we read in a file. But let's go to read in database CPP. Well, database read is going to return a two-dimensional vector of strings, so we don't actually do anything with this two-dimensional vector. So we get the vector here, we fill it all up, we return it, but then we don't use it in main. So that's my problem because I didn't use it here. And I do want to use it, and I want to pass it into simplelist.mainList. So it's as simple as doing this statement here. So now I'm saying the simple list main list, which is of the type class list, will now be equal to whatever is read in from the database. So right here, this main list becomes whatever is read in by the database. That should fix things. then we'll have a record of the main list, and then we can find the user inside the list. So let's go ahead and try that again. I'll go ahead and just make clean and make once more. Run the program. And that was definitely one of my issues, but not my only issue, because I'm still not seeing it. And my problem was that I didn't make a save up here. So let me go ahead and save main CPP, run this over again after I make clean and build the program again. I'll run simple list with Savvy Nick, and then this time we have actually found a user, Savvy Nick. The user has been found, Savvy Nick, so that's great. Looks like everything ran properly there. Now the next thing I want to do is, we do currently have the ability still to print the menu, so let's go ahead and print the list and see what we get. Look at that, item 1, 2, 3, 4. So we didn't make any edits to the print list function, but since we used the two-dimensional vector to go ahead and just pull out one list from a certain user that was found, we just passed that into our list h vector string list. And then we went ahead and used the same function to go ahead and display that list. So it found all these items in the list. Now, of course, we probably don't want Savvy Nick being displayed as the user, which we can make an edit to the print list in order to go ahead and delete the very first record here. That way it's not showing that one. Otherwise, things look great. So let's go ahead and make a change to the list and see if we get a proper update when we print the list. So if I hit M here and I quit out of the program with 4, then I'm going to go ahead and make a simple change here and just add another item, item 5. So if I save that item and then I go ahead and just simply rerun the program, it says, welcome Savvy Nick, user has been found, Savvy Nick. And let's print our list out and look at that, item 1, item 2, item 3, item 4, and item 5 now, which is what we have in our list. We also have a second user called Savvy Bob, so let's go ahead and test him as well. So I'm also going to quit out of the program once more and then change my user to Savvy Bob. What happens if we do that? Look at that, welcome Savvy Bob. So we did first iterate through and find Savvy Nick as a user, but we skipped that, went to Savvy Bob, and then we found Savvy Bob. And let's see what's in Savvy Bob's list. We have item 5, 6, and 7. Well, this is really starting to get exciting now because we are able to read and write out of a database and keep track of those items in our local program. First thing I wanted to do is fix our write function from last time. So in database CPP, we have this database write function, and I know that it's currently not going to work. So if I went ahead into main CPP, right now we're not even calling that write function, but if we did, I think we'll get a seg fault. So let's just give it a shot. I'm gonna go ahead and save that, and we're not calling it simple list anymore. We're calling it the main list from last time. So I'm going to put that in, and that should resolve that issue. After I save, I'm going to go ahead and launch a terminal. And in the terminal, I'm going to go ahead and build the program. And then I'm going to run it real quick. Let's see, with Savvy Nick should be fine. Can we print our list? Yeah, we have items in our list. Now, if I quit out, that should cause a seg fault, and it sure did. Reason being is because we aren't properly going through the vector here in our write function, which we haven't used in a while since we were going and reading in the database in the last video. So we could edit it per user. What I really need here is, instead of a user's list size, I don't want the user list size. I want to go through every single user, which is part of the first vector in the two-dimensional vector we created. So you have main list dot size, and then you have main list user index dot size. So this one's going to be wrong as well. So we need to remove the list index because we don't care about the size of a specific item. Instead, we care about the size of the entire list. So this will give us the size of all the user lists, and this will give us the size of one specific user's list. That way we can go through any and all lists and write them out to the database file that we've created called lists.sl. I think that will be good for now. And I'm just going to save that. And then in list.sl, one thing that we're doing differently is we're writing this percentage sign as well as the hashtag, which the hashtag is currently denoting the username, and the percentage sign is denoting where we're going to go ahead and stop our list. So we have to create that here when we write our database file out. Otherwise, we'll be missing the hashtag and the percentage sign. First thing I want to do is go ahead and put an if statement. So if the list index is equal to 0, what does that mean? Well, that means it's a username. So we can take advantage of the fact that it's the first item in the list. And if it is, that is the username. So let's go ahead and print out the username into the database. So like we said, we'd use a hashtag for that. So what we should do here is add a hashtag in first, followed by the main list user index, list index. So this is just going to write an item out. And since it's the first list indexed item, it's going to be the username. So this should be fine. We need to do something else here. So let's go ahead and just take advantage of this again and go ahead and paste it in and indent it a few times to make the formatting right. So looking back at our list.sl file, we'll write out this hashtag and then a username followed by our items, which is this portion of the code now. So it's just going to go ahead for the first list item, go through here, and then for the second list item, it's going to go through this else statement. So that also applies to the third, fourth, so on and so forth. As many as you have in the list, it'll continue printing them out. So that means after it's printed out all the items, what is it going to do next? Well, we need to go ahead and put a percentage sign in order to delimit our list. So let's do that. So we're going to have to do that after the second for loop here. So if we do it right here, that means a user's list has stopped. So this for loop is for finding a user, and this for loop is for the list of items for a specific user. So after we've gone through and added all the items to the database, we need to go ahead and place that percentage sign. So this will be the perfect place to do it. We'll do db and just put a percentage sign. So we got a string percentage sign and a new line character. Close that off, save that, and I think we can go ahead and test this real quick. So if things work correctly, I believe we should get this same exact list written back out to us. So I'm going to launch that terminal real quick. Let's just build with make real quick since we made changes and rerun our simple list with, let's say, Savvy Nick here. And what I'll do is simply just quit out of the program. And as you can tell, we did not get a seg fault this time, and it looks like we've actually rewritten the file with what used to be in there. So that looks like it worked pretty well. All right, and now that we can write in and out of the database, we need to fix a couple things in order to be able to create new items and also save them out to the database. If you went ahead and made it this far, please hit the like button. It really does help me out. So the next thing I want to do is go to list CPP, and I want to add another function. So I'm just going to go to the bottom here and add one more function. I'm going to call this one save list, and it will be a function to the class list. And we're just going to do save underscore list. And this one should be fairly simple. While we're at it, let's go ahead and add this also into our header file, so list.h. And we'll just add it here below. This is a void. And it should be as simple as that. That should correct our problem here. No more red indicators, so great. Next, I want to just write out a little bit here so they know we're saving their list. We're just going to put saving the list, ... And let's just put a new line character at the end here. Later, we're going to have to keep track of the user who's using the application. So let's go ahead and add in a member variable real quick to the class. So I'm just going to call this, it's going to be an integer because it's going to be a number. And I'm going to call it current user index. So that's the current user and what his index is inside of the vector that we are going to keep track of their list in. Then going back to list CPP, and in the save list function, let's go ahead and do main list and the current user index. Since that's going to be the current user, we're going to save their list. That way, if a user makes any edits, their list is saved into the main list, which gets written out to the database. So it's as simple as that, but let's go ahead and display the print menu once more. So we'll just put that print menu function call right here. So it goes back and prints the user menu. And since we just added this current user index member variable, let's go ahead and apply it to our find user list function. So in the last episode, we went ahead and made this function so we can search for a user in the database and pull up their list. So what we want to do is keep track of that user and where they show up in the main list vector. So we can do that pretty simply by just adding a line here and saying that the current user index gets set to the user underscore index, because if we do find the user inside this main list that we read from the database file, then we'll just say, hey, we got to this index and we need to store that index in the current user index for later use. So what happens if we don't find a user? Well, you're going to go through this for loop. You're going to go through the entire list that you read in, and then you're going to do a little bit of a check. So if user found is equal to false, meaning we set it to false up here, and meaning it never made it into this if statement where it found a user, so user found gets set to true here. We're going to look for, again, user found equal to false. And if that's true, we're going to go ahead and take advantage of the fact that our list is going to be empty since it didn't find a user or a list. And since that list is going to be empty and we already instantiated it, we can just say, hey, let's push back our name. So that's the current user using the program. And we're going to take main list and push back that list into our main list. So push back the list after we've added a name in. And finally, we're going to say that the current user index, since we were going to specify it here if we found a user. If we didn't find a user, we need to create a new entry in our list. I'm going to cast this as an integer and say that the main list dot size -1. Since we start with 0, the size will be 1 more than the actual size of the complete list, so we want to make sure to subtract 1, and just hit save. One thing we haven't done is, since we do keep track of this Boolean called user found, in case another developer wants to be able to check if a user was found or not outside of the scope of this function, what we can do is return a type. So if we say return user found, the program's going to complain right now because it says you can't return a value because you said it's a function that returns a void, meaning nothing. So we have to also change this void to the variable type that we defined for a return parameter. So it's a Boolean because user found is a Boolean. So we must specify we're returning a Boolean outside the function. So if we save that there, we also have to make an update here so that the two functions match inside the class as well as inside the function. Now that we have that, you can see that there's no complaints. And this is a nice thing to have for some of your functions, because then another developer could come along and use conditions based around your return parameters out of a function that you created. So let's just say we did bool, and we're going to call that bool user found again, and just set it equal to this simple list file user list. Because this function does actually return something, we can do this. If you call this function is going to return something, and what's it going to return? It's going to return a Boolean called user found. Since we're in a different scope here, we can again use user found, and then I can do a test based off of this. So I could actually do user found equal to true or false, and then do some statements inside of this if clause. So I'm not going to do that though. It's just nice to have sometimes, and I don't have a use for this right now, so I'm going to go ahead and get rid of that. A little bit of cleanup, since we're already reading in up here, we don't need that called twice. And since it was commented out, it's not doing anything. I'm just going to erase that function. All right, and then in list CPP, we created this new function called save list, but we did not make a call to it, so we have to do that as well. I figure let's just go ahead and add a new menu item and then make the function call. So what I'm going to do is just change the choice for quitting out of the program to number 5, and then create a new else if statement that takes care of the new choice, which will be 4. And then I'm going to go ahead and just call save list in here. And then up here, I'm going to add in a new choice, and we're going to say 5 is now quit and 4 is save list. And we'll save that. And I believe that's all we need in order to run our program. So let's go ahead and give it another shot here. We'll first build our program in a new terminal. So we'll do make, give it a moment. And I did change a header file around, so let me first make clean and then make again. And now I'm going to run simple list with savvy Nick. Let's see if we pull in our list. So print the list. You can see we have item 1, 2, 3, 4, and 5. Does that jive with our list here? Yes, it does in our database. So we have the 5 items. Let's go ahead and try adding a new item. So I'm going to go back to the menu. I'm going to say add to list. Well, we got item 1, 2, 3, 4, 5. Let's just add item 6 and see if that pops up. After we save and quit out, because if we look back at main, we have to get out of the print menu function before we write to the database, which means we have to quit. And if we just look at list CPP, you can see here choice number 5 or quit will return out of the function, and then 4 is going to save our list. So we have to select 4 and then we have to select 5 in order for our list to update. So first I'm going to go ahead and save it. It says it's saving the list, so that's a great thing to see. The call was made correctly. And then finally I'm going to go ahead and just hit 5 to quit out of the program. And you can see that our list got updated. So you have item 1, 2, 3, 4, 5, and then you have item 6. So that looks like it worked very well. Our program was able to go ahead and append an item to the list for a specific user that we specified. So let's go ahead and try Savvy Bob now, just to make sure things are working properly as well there. So we're going to enter in Savvy Bob. I'm going to add an item to the list, item 8 for Savvy Bob. And I'm going to save the list, exit out with 5, and you can see now we have item 8 in Savvy Bob's list. So the next thing, what if we want to add a brand new list and a new user? Well, let's give it a shot. So let's do Savvy George. It says, welcome Savvy George, and then we have a couple debug statements here where we're printing out some usernames. Let's go ahead and add to our list a new item, and let's just continue with item 9, and add to the list item 10, add to the list item 11, and print that list. You can see Savvy George has item 9, 10, and 11. Let's go back to the main menu. Let's save that list and quit out. And you can see it added a whole new user named Savvy George. Because it didn't find him in the database, it went ahead and just appended him to the end. So what happens if we call Savvy George this time? We should be able to print his list, and we do. You can see item 9, item 10, item 11, which matches up here. Let's go back to the menu. Let's actually delete an item this time. So how about we delete the middle one, which is index 2, item number 10, and now print the list. You can see we only have item 9 and 11. I'm going to hit back to menu and then save the list and quit out again. And you can see it deleted that item in our database as well. Same thing should work for Savvy Nick. So let's try that out and delete from the list. Let's delete a few items out of this one. So I'm going to delete index 2, which is item 2, and then delete from the list. Let's see. Let's do index 2, item 3, and let's delete one more. Index 2 again, and we'll print that list. So item 1, 5, and 6 is what we should see after we save the database and quit out of the program. And that's exactly what you see. So Savvy Nick now has item 1, 5, and 6. And congratulations, if you've made it this far, you now can successfully, with your program, add items to lists as well as create multiple lists with different users. This is very exciting because we do have a functioning program at this point. Sure, there's ways to mess it up. Right now, I could think of a few. What if we went ahead and deleted the username from the list? What would happen then, or would our program care? But we've definitely come a long way from initially just setting up Visual Studio Code and talking about our first steps to create the program. And at this point, if you followed through the series, you've used things such as vectors, classes, objects, various different functions and data types, all to make a fully working program that even saves your output to a file and reads it back in next time you start it up. This has great practicality for going through various files, reading them in, organizing your data, and then going back and spitting out that data into a file, which is also known as parsing through data. And I hope you find some use for these methods that we've used in this series. First thing I want to do is go to the debug button over here. If you see this little bug, you can click on that, and this is where we can run our debugger from. Assuming you haven't already created a debug configuration in Visual Studio Code, let's go ahead and start here. Also, if you're new and stopping by to watch a programming episode today, please make sure to go ahead and subscribe and hit the notification bell for future videos. So let's go ahead and click on the create a launch.json file. This will create a new debugging configuration for us. And as you can tell above, it's asking us to select an environment. So we want the C++. I'm going to use the GNU debugger in order to debug with today. So as you can tell, that's one of the choices here, GDB or LLDB. And once you click that, you'll get an automatically generated launch.json file for the debug configuration. So the first thing we want to do here is change the program key value pair up so we can go ahead and launch our file. And since it already has an example for us, it actually has enter a program name, for example, and then it has a workspace folder, so the current workspace that we're working in, / a program that they've compiled called a.out. Well, that's not the name of our program, but we can make use of this. Let's just go ahead and get rid of everything in front here. We'll keep the workspace folder. And now instead of a.out, our program is called simple list. So that's what I'm going to go ahead and put in here. Also, our program, if you haven't been following along, does require a username as an argument, so we can actually type in multiple arguments here as another key value pair of a. So I'm going to go ahead and put in SavvyNick as a username that I'm going to pass into my program at the beginning. And that's really all the changes that I need to make in here. So I'm going to go ahead and make sure to save this, and then I'm going to go back to my program because it will take just a little bit of editing in order to make sure that we compile the debug symbols. Instead of just executable code, we need those debug symbols in order to be able to debug the program. So in order to make that change, I'm going to go to my makefile. And then I'm going to take a look at my compiler settings. It says here that it can be customized. If you need help setting up the Visual Studio Code environment, make sure to watch the first video in the series, and to set up a makefile that can compile the code, watch the second video in the series. Again, I also have a Git repo available on GitHub, so you can reference the project as the episodes have progressed. So in order to go ahead and build with the debug symbols, we need to actually add a new switch. You can see here that we have two switches, the dash wall and the standard. We're using C++ 11, which is the version of C++ that we're currently using. I'm going to put a space here and I'm going to add a dash G. This will make sure that we compile the debug symbols and the program can be debugged. And that's really all we need. So let's go ahead and make a save here. Otherwise, you might get some errors trying to launch your program in debug, so don't forget this step. And now after we've saved this, we can go ahead and go back to the debugger, and let's go ahead and click on that. And we have, if we click on this drop down, it says a GDB launch. So that's the current selection. If you have multiple debuggers or configurations, you can select from this drop down, and then you'll be able to hit the run button in order to start debugging. So if we've successfully set everything up correctly, I believe we should be able to start debugging at this point. So I'm going to go into the debug console just to make sure that we get some kind of messages from the debugger. And I'm going to hit the run button. So here we go, we got an error. It says that our simple list program does not exist. Well, that makes sense because we haven't compiled it yet. So let's go ahead and cancel out. I'm going to go back into the terminal. If you need to get into terminal, you can always hit terminal, new terminal. And in here, I'm going to do ls just to see what I have available. And of course, I see that simple list is not available. That's because we never built it with the debug symbols. In order to do that, I'm going to have to type in make and let it build. Now you can see every object got compiled with this -G flag, which is a great thing. So let's go ahead and try again and run the debugger. If we run it this time, you can see that something's happening here, and our debug console says that the symbols were loaded successfully, which is great. Now we go back to the terminal and our program is running, which is another great sign. What I'm going to do is I'm just going to type in 5 to quit out of my program, which will quit out of the debugger as well. But in order to make this useful, let's go ahead and open up a CPP file so we can set a breakpoint. So in main, I'm going to set my breakpoint at the very first line in main. You can do that by going to the left-hand corner of any of the numbers here. So these are representing the line numbers. And you'll see a little red dot pop up, and as soon as you click on the line, then you can add in as many breakpoints as you want. You can also get rid of the breakpoints. Breakpoints are just where the debugger decides to stop as soon as it gets to it and allows you to make a choice on what you want to do from there. So what we'll expect is in main CPP, the debugger is going to allow the program to run, and as soon as main is called, it's going to stop on line 5. So let's go ahead and make sure that that does happen. I'm going to go back into the debugger and hit run and give it a few moments, and look at that. Now we have our first breakpoint that was made. You see this little yellow arrow around the red dot now, meaning we are currently on this line, and that line is highlighted. Once you do launch the debugger, you'll also get some tools up here in order to use your debugger. If you went ahead and made it this far, please take a moment to hit the like button. It really does help me out. And these choices up here allow you to actually use the debugger. So if you hit continue, that's going to go ahead and continue on with the program until it hits the next breakpoint. Well, since we don't have another breakpoint, it's just going to keep running the program in the normal mode. So if we select the step over option, that will step over to the next line of code. So we would expect if we hit this, we would go to line 6 here. Step into allows us to go ahead and step into function calls, so we can see what that particular function is doing instead of stepping over it. Step out allows us to get out of the function and go to the next line that's going to be ran. And then restart, of course, restarts your whole entire program, and stop completely exits out of the program as well as the debugger. So this is really the bulk of being able to debug, is stepping through your code and stepping in and out of functions to figure out where problems might lie. So currently this is a fully working program. I'm not searching for anything in particular, but let's go ahead and use these tools a little bit so we can see how things are getting populated and used. What I'll use is the terminal as well as these buttons up here of the debugger. And then the left-hand side, we have a few more things which I should make mention of. The first thing we have up here is our variables. This is keeping track of local variables on the stack. So you can see we have a simple list, some data, an argument count, and where our arguments are located. So these are arguments that are passed into the main function. As you can see here, we're requesting some arguments, meaning our program name as well as the program user. So if we open this up, we should see a few things here. Let's go ahead and open this up even further. And you do see in this first memory location, this is currently the directory where our program is located. So we're not going to get too deep into that. You see this is a memory address, and in that memory address we have home, SavvyNick, desktop, simple list available to us. Now this isn't drilling down quite all the way, so we can see the username as well, but you get enough information for now, and you kind of get a good understanding of what these are. So we'll check out simple list and data, since those are things we populate on the stack. And then the second thing is using watch, an expression we want to watch, perhaps in a function that exists. I know I have one called user index, which shouldn't really show up because it's currently not in the scope of things, but it says unable to create the variable object. Well, that's fine, that's expected, but maybe if we get into a function, we will be able to see what this user index looks like as we're stepping through the program. Finally, at the bottom, we have the call stack. So this is the current function being called and all the previous functions that had been called in order to be in the current function. So you can see that main is the only one currently on the call stack, so that's the only function that has been called. We'll review this a little bit as well. And then at the bottom you have any breakpoints that you currently have set. If you set more than one breakpoint, you can see that multiple breakpoints are getting populated below, so you can keep track of them easily in here. So let's go ahead and step through our program. So the first thing I'm going to do is just hit the step over function. As you see, we just went to the next line, and I'm going to hit step over again. And we can see that the argument count is now 2, and that's what it says in our variables up here in the local variables as well. So argument count is 2, which is greater than 1, so we would expect when we hit the step over to go down here to line 9, because this if statement is true. So I'm going to go ahead and hit that, and we get line 9. Now we can see that the args array, specifically the second element inside of the args array, is going to be populated into a string that's of the object simple list.name. So we would expect this name to become some type of a string here after we hit step over. So let's do that. And we can see that simple list.name is SavvyNick. So I wonder if we go ahead over here and actually type that in, can we see that name? And I do. So I did simple list.name, it's a string, and what's that string? It tells you right here, it's SavvyNick. So that's what we passed in to our program. So now I'm a little interested in reading my data. So right now, if we were to hit step over, we just go to the next line, and it'd completely ignore the fact that we are calling another function here. It would just do whatever this function is meant to do and save it into this simple list main list but I'm more interested in the function, so I can always step into it. So if I hit the step into, you'll see that now we're actually in the function call. Let me make this a little smaller so we can see this a little better. And here is where we read in all of our data that's currently located in our database file. So instead of going through all of this, I'm going to actually allow this to run a little bit. And now I can go ahead and step out of this function because I don't want to run through the whole function. And as you can tell, it stepped back out and it grabbed some information because the function was actually called. And it says it found a hashtag with Savvy Nick and some items and a few more users, so that's great. Next thing we can do here is go ahead and step over once more. Now find user list is the next function call. So this function is meant to find a specific user that was specified by the console. So it's going to search for Savvy Nick and see if it can't find it. So this might be a good function to go ahead and step through as well. So I'm going to go ahead and hit step into. You can also use F11. It makes things a little quicker. And to step over, you can use F10. So I'm going to start using that. So it makes things a little easier on me. So we're getting to this first for loop, which is going to search through the user indexes of a vector in order to find a username. So I'm just going to keep going here, and the first line that we're stepping over here is going to print out the first username it finds in the 2D vector that we have, welcome, the username that we got from the user, and then in this for loop we spit out the very first name available. So something we can do as well is go ahead and add this to our watch, and we should see, okay, it's Savvy Nick is the current user in our list, as well as what's the name we're searching for, Savvy Nick as well. So we would expect this if statement to be true. So I'm going to hit step over and we'll step into this if statement. And now it's going to tell us the user has been found once we execute this line. So I'm going to hit step over and look at that. User has been found, Savvy Nick. So if we keep going through here, we're going to break out of this for loop, and now we're going to skip this if statement because we did find a user and it was true, and we're going to return that the user was found. So if we step over this and step over once more, we'll actually go back into the main CPP file so we can call our next function since find user list was ran properly. Simple list print menu is where we actually ask the user what they want to do with the list. So let's step into that one as well. And I want to kind of show you what the call stack does this time. So if we step into, you can see that main just made a call out to lists an object. And in that object, print menu, the function was called. And as you can see, print menu is currently the one highlighted right here. So I'm just going to show you that as we're stepping through, you'll see these couts or prints to the console being displayed here in our terminal because our terminal is still running our program for us and the debugger is just pausing it on every single line here. So I'm just going to hit step over, and as you can see, now we have the asterisk as well as now print list. I hit it again. So what if you want to skip over a few statements? That way you don't have to step one by one through everything. You can always put in another breakpoint and hit the continue button. What this will do is jump until it gets to the breakpoint that you set. So it makes things a little easier to go around if you don't want to look at a bunch of lines such as these couts that I have. And you can see everything got printed out like normal. What I want to do now is hit the step over, and now the debugger is currently in a pause state because the terminal is waiting for you to enter a choice in order to continue the program. So we can do that by saying, okay, what do we want to do? Do we want to add to the list? Do we want to delete from the list, etc.? I'm actually going to do a breakpoint here on line 29 for me, print list, and I'm going to go ahead and choose that choice, so print the list. So that's whatever is currently in that user list, the console is going to print out. So if I put in 1, you can see that our program continued down to print list. I can also remove this breakpoint so it doesn't stop here every time we have to enter in a choice. So I'm going to do that. And now that it's in print list, I'm just going to go ahead and hit continue, which will allow us to run our program until we choose choice number 1 again for print list. So let's go ahead and just do that. You can see that the list got printed out to us. So we have Savvy Nick, the username, and a few items here available to us. I'm going to go back to the menu by hitting M, and I'm going to go ahead and select print the list once more. And you can see that we got our breakpoint once more up here. So the program can't run until we go ahead and hit continue, or step through it with step over or step into if we want to see what this print list function looks like again. And since we've already seen it, I'm not going to do that again. The only other thing I'm going to show you, sometimes you lose track of everything and you have to be able to start back from the beginning. A very nice option here is the restart button. What that will do is restart the debugger completely, restart your program, and as you can see here, it did just that. It started at the very first breakpoint in main that we went ahead and put into our program. So the last thing I'll show you here is just some of these local objects getting filled up. So I'm going to go to actually line 12 here because line 13 won't get executed unless we exit out of this function. And I'm going to hit continue. So we got all the way down here. So now I would expect some information to be both in our simple list. So simple list is comprised of a few things here. It has a 2D vector called main list. It has a one-dimensional normal vector of strings called list, and then a name and the current user index to keep track of. So that's all part of this simple list. Data is another object which keeps track of our database and gets information in and out of it. So I'm just going to focus on simple list now. As you look through these, you can see that you can tunnel in even further to these objects. You can see main list found 3 different vectors. So you can see here that we have a vector of strings located in another vector, which keeps track of a vector of lists. So there's multiple lists available because there's multiple users, see, Savvy Bob, as well as Savvy George and Savvy Nick, just like we have in our database file. So let me just bring that up so you can kind of correlate the two together. So in our database, lists.sl, you can see that these items and usernames that we have over here have been parsed through to exist inside of this object called main list. And then we manipulate main list in order to change this database around. So debugging in Visual Studio Code is a great thing to understand and use, and can be a very powerful method to go graphically through your program and figure out how to handle certain problems or bugs that you come across. There is a little bit of fine-tuning in order to get your program to work with Visual Studio Code if you're not using all the native tools. And since I'm not using all the native tools, aka using a makefile to compile my project, it does take a little bit of extra work to make your program be able to be debugged by the Visual Studio IDE through a debugger such as the GNU debugger. Well, that's really all the debugging I wanted to do. I just wanted to be able to give you some general knowledge of how to use the debugger as well as how to set it up here in Visual Studio Code using a makefile to compile our program. Let me know if you have any questions, comments, or suggestions. Please go ahead and make sure to post them in the comments section below. Also, make sure to subscribe for future videos and make sure to like this video. Thanks for watching.